job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello and welcome to DevCon 2021 Day 2. I'm Ron Burgundy and I'm Steve Shadders, the CTO of nChain, and I will be your host throughout the day. We saw some interesting stuff yesterday with an array of SDKs and some pretty intense live coding exercises, and we've got more of both today. We'll be hearing from Handcash, Electrum SV, Chronoverse, and many more. Just a quick note on the airdrops. We noticed a few questions from people who are trying to scan the QR code and not getting the result that they expect. Rather than actually scanning it from inside the Handcash app, if you already have it installed, just scan it with your camera phone, because the QR code is actually will take you to a Handcash install screen if you don't have it installed. If you do, it will take you into Handcash and you'll be okay to run from there. So what else do we have today? We've also got Jiawei Liu from Script, who'll be delving into some of the mysteries of op-push-tx. The Chronoverse guys will be showing off the Fix SDK, and I'll be joined shortly by Mate Trampush from nChain, the engineering director. So we'll get to that in a moment. Do please stay tuned, because at the end of the day we have a bit of an announcement to make. But let's just get on with things, I think. Shortly, I'll be joined by Mate, as I say, the engineering director of nChain, probably the man who knows more about the fine details of the Bitcoin SV code than anybody on the planet. And we'll be exploring some of the new features of Bitcoin SV. Some talk about long chains, where we came from, how we got here, and where we're going to next, as well as some new transaction types that bolt-on features that you can add on to transactions to complete some of the work to make Bitcoin the most usable blockchain in the world. So I'll be back in just a few moments with Mate, and there'll be a Q&A afterwards. So please do get your questions ready. Just before we go, actually, don't forget there is the Q&A form on the page. If you're watching on the YouTube channel, you probably have to go back to the We Are Devs page, or no, I think you can actually post questions in the chat on the YouTube page as well, and someone is transferring those over. So we'll see you shortly for a dig into some of the new features of Bitcoin SV and some of the new ways that you can use the Bitcoin network. I'm Steve Shadders, and with me I have Mate Trampush, who is engineering director at nChain and one of the main brains behind the Bitcoin SV node project. We're here to talk to you today about a few different transaction types and ways of constructing transactions to enable some novel use cases. We're also going to cover one of the hottest topics in Bitcoin over the last couple of years, which is the lengthening of chain transaction or chains of transactions with the raising of the ancestor limit. And Mate is going to go into some of the detail as to why it was actually such a hard thing to do and what we've done about it. But I will begin. And here. We're going to start today by talking about a new class of transaction called dust return. First, I'm going to explain what the dust problem is and how the dust return transaction deals with it. So dusting, or the dusting attack rather, is a pretty well-known phenomenon on Bitcoin. It's been going on for many years. And it's a mechanism of basically breaking the privacy of Bitcoin users. So the dust attacker starts with a list of Bitcoin addresses which they've harvested from the public blockchain, because of course the first time you use an address, the address gets put into a transaction, the transaction gets put into the blockchain, and that of course makes it public. So the attacker begins with a whole list of addresses that, that don't apparently have any relation to each other, as far as they can see at this time. And if you never reuse an address, of course, they'll never be able to derive any connection between one address and another. So the dust attacker actually begins by sending very small amounts of Bitcoin. And when we say dust, it's commonly brought up in the context of the dust threshold, which is an amount of Satoshis which is so low that you can't actually spend it economically. In this context, the dust is actually slightly higher than that, because otherwise, normally the Bitcoin miners would reject transactions that contain them. So by reusing existing addresses and sending these small amounts of dust, it's a fairly inconsequential cost to the dust attacker. They can send them, and they basically arrive in the wallet of the person that had used that address previously. Now, that doesn't necessarily matter until such time as later on you go to spend some Bitcoins, and your wallet then goes through and tries to find some inputs that are unspent. And of course, if you spent the one where the address was initially published onto the blockchain, that's not going to be selected. But you've got this new one here now, which is the one that originated from the dust attacker. If your wallet software is not smart enough to be aware of this, what's very likely to happen is that they'll collect one of these dust inputs along with one of your real legitimate inputs and use both of them in a transaction, which creates a link between the two. So note that the inputs to this transaction are actually different addresses, but because they've appeared in the same transaction, it's reasonably easy to infer that they came from the same wallet. So now that you've used this dust input, those outputs are all connected, and as I say, they're identified as part of the same wallet. This is, of course, a privacy concern, but it also creates other issues, which we'll get into in a moment. The mitigation for this is one that is not necessarily universally adopted by wallets, which is identified dust that's come into your wallet and then never spend it. So this has a few downsides, one of which is your wallet basically has to keep and maintain this dust forever. Your wallet needs to be smart enough to ignore it and to remember to continue ignoring it forever. And of course, because you're ignoring it, these Satoshis that are locked up in this output basically will sit there forever, unspent, and they become an entry in the UTXO database, which is a permanent burden, essentially, for the miners. As the number of these dust transactions increases, so does the size of the UTXO database, which contains a whole bunch of entries that are effectively there for no reason, because they'll never be spent, but the miner can't rule out the possibility that they will be spent. And if they do, and the miner has deleted them, then the miner's going to be in trouble, because they'll fall out of consensus with the rest of the network. So we've come up with a new way to address this problem, to clean it up. And it's essentially a special type of transaction called a dust return transaction. It effectively becomes a donation to the miner, and we'll get into the details in a moment of how you construct one. But it basically allows you to send the dust out of your wallet to a miner. So it has a couple of net benefits. One is the dust gets cleaned up. It's out of your wallet. It's out of the miner's database. The attacker actually learns nothing because we do this in such a way as there's no connection between the dust that they've sent you and any other input in your wallet. This basically removes the incentive for the attacker to perform the dust attack in the first place. In fact, it turns the incentive into a penalty because they still incur the cost of doing so. It might be small, but add up over, if a dust attacker is sending out hundreds of thousands or millions of dust outputs, it adds up to something significant. And if they gain nothing from it, then they actually have no reason to do it. And the final and probably most important one of the benefits is that the Satoshis that get locked up in this dust are actually allowed to return to circulation. So what does a dust return transaction look like? It's got a few rules around what defines a dust return transaction. Firstly, it has one input, and in fact, it doesn't have any limit on the number of Satoshis that are in the input. You could actually spend 10 BSV in a dust return transaction if you wanted to, but you probably wouldn't because you'd be giving it away, essentially. The dust return transaction has one single op return output that has the protocol identifier dust, or actually it's 4 bytes, which is the ASCII bytes for the string dust. And this requirement is there for a specific reason, because if you allowed additional data or any other sort of data in the transaction, it would effectively become a free mechanism for data carrier. The other important requirement is that the value of the output is set to 0. This means that the entire input value essentially becomes a donation to the miner via the transaction fee. If it doesn't fit this pattern, it doesn't get classified as a dust return transaction, and it will be evaluated against normal fee limits, according to the regular sort of fee evaluation rules. But if it does, then it becomes an exception, and the miner will accept, by default, will accept these transactions regardless. So I probably should have been scrolling through these as I explained. So that's it. It's really simple to construct these, and the end game would be, I suppose, that wallets would actually be aware of this dust return transaction type. When they detect a dust transaction coming into the wallet, they would then prepare the dust return transaction, and the next time the user interacts, usually wallets require some authorization from users to sign transactions. They prompt the user and say, would you like to clean up dust? If the user clicks yes, then the wallet would sign those transactions and send them out. And that's it. Your wallet's clean of all of the dust, and the attacker has learned nothing. There are a couple of additional parameters on the Bitcoin D side. We don't need to go into too much detail for them, but this is a feature that, of course, is configurable. You can turn it off if you want to, but these are details that are probably more important for the miners who are operating this as a service. And that brings us to the next type of transaction, which is the consolidation transaction. And they actually happen to share a couple of config parameters, but again, these are important on the mining side. And the second one, the consolidation factor, is probably the most important from the point of view of consolidation transactions. We'll get to explaining that one in a moment. Now, consolidation transactions have actually been around and enabled for quite a while. It was late last year, maybe October last year, I think, that they were first enabled. And that led to a lot of interesting conversation about the concept of nanoservices. There is an article on the Bitcoin SV website, bitcoinsv.io website, that goes into quite a lot more detail about consolidation transactions, but we will cover some of the basic elements of them here. So what are they? If a transaction that reduces the number of UTXOs by a margin that is more valuable to the network than the implied fee, then it enables use cases for transactions that might normally be uneconomic. And the general idea is that aside from being another mechanism for cleaning up dust, it's different to dust return in that it does have privacy implications. It also enables what we call nanoservices that basically allow software allow services to piggyback on top of transactions that were already going to happen anyway. So what do they look like? So over here on the left, I've got a list of 1,000 transactions, and I've sort of squished that list up a little bit because otherwise this slide would be very, very big. And we're essentially feeding a lot of outputs that are of a value that would normally be considered dust into a transaction as inputs. We then basically are able to add all of the values of those inputs together into a single output and consolidate the value for 1,000 inputs in to one input out. And you can see on the output side, we've now got 10,000 Satoshis, which is actually a useful amount. And if the right conditions are met, then we can class this, or the Bitcoin SV software rather, classes this as a consolidation transaction. And it allows it to go through with 0 fee. We'll get to the reasons why miners might want to do this later. This is the next transaction in the chain where you actually make use of it, and you can see it's a normal Bitcoin transaction that's got a fee of 250 sats in this particular case. So benefits for the Bitcoin network, the UTXO size has basically been decreased. We've taken 1,000 inputs and turned them into one. That means that every miner can now shrink their UTXO database. And of course, the dust itself becomes useful again. So let's talk about how this is actually potentially useful. Well, cleaning up dust is one way of doing it, but we've got the dust return type of transaction now that essentially solves that problem in what I think is probably a more elegant way. But dust return allows basically any service provider to accept extremely small payments for what I've termed to be nano services, with the expectation that even though what they're charging is lower than a transaction fee that would be required for them to spend it, they can consolidate those later. So here's an example: Merkle proof return. When you submit a transaction to a miner through Mappy, you can optionally ask for them to send you back a Merkle proof later on. Now, miners might want to do this for free, but they might also want to charge for the service. But it's a very, very small service. It requires a HTTP call to an SPV channel server. That's pretty minimal service level. You probably wouldn't normally be able to charge enough for a service like that to make it be worth more than the dust limit. But in this case, you can charge as little as 1 Satoshi for providing that service. From the miner's point of view, it's a net benefit, because if you choose that particular miner to submit your transactions through and ask for your Merkle proofs, they'll still get that Merkle proof fee regardless of whether or not they mine the transaction. So that would mean that you would construct a transaction that has a normal transaction fee that would be collected by whichever miner mines it into a block, but it also has an extra output that pays this particular miner 1 Satoshi or 10 Satoshis, for example. And of course, later on, they collect them all up, pick them all up. And just to give you some ideas of other ways that you could make use of this, insurance is one. We don't think that double spends need insuring anymore, but there used to be services like that where you actually could buy double spend insurance for a transaction. The insurance could be for something else completely unrelated, but related to the transaction. So this insurance might be on a per transaction basis, and it might be a very, very low amount. So again, if the amount was, the cost of the insurance service was significantly above the dust fee, wouldn't be a problem. But if it's close to the dust fee, even if it's double of the dust fee, it means that half of the, a significant chunk of the cost of that would have to be paid in transaction fees later on in order to consolidate them. So again, it's another example where you can take a transaction that was going to happen anyway and add value-add services or purchase value-add services related to that transaction for very minimal amounts. Another example, which we're going to see a lot more detail about from Mate, is double spend notifications. This is a service that's not normally provided by the Bitcoin network. It can be provided by individual miners, and they may or may not want to charge for that. Something that's completely unrelated to the business of putting together Bitcoin transactions might be micro taxes. Or taxes rather for micropayments. So imagine sales tax. It's a common scenario that we talk about in Bitcoin, creating a Bitcoin transaction that actually pays not just for the service that you're receiving, but it pays all of the suppliers and it even pays the tax, so all in the same transaction. Normally that will work okay if you're buying something worth $10 or even $1. The transaction fee is fairly trivially small in comparison to the main payment or even some of the broken down sub payments like the VAT. But what if you're buying a microservice? What if you're buying something that's worth a cent? Then the VAT on that is actually worth significantly less. There is some point in that value curve where the microservice itself is economic in terms of being able to pay a Bitcoin transaction fee and that not being a significant amount of the cost of the microservice. But the sales tax, which is a small percentage of that, actually does fall below that threshold. So this is another classic example where you can pay that directly to whichever tax department happens to live in your country, and they can collect them all, consolidate them later, and incur no fee losses in doing so. So that brings me to the building of a consolidation transaction. We've imposed some limits on how a consolidation transaction is defined, and this is specifically for the reason that if you don't do this, it becomes reasonably easy to try and exploit this as a mechanism to get lower fees anyway by just taking an existing output, splitting it up into many small ones, and making payments using lots of the small inputs to basically get zero fee. The maths is quite complicated, but there is a point where that is actually economic to do and cheaper than just paying the transaction fee that you would have had to have paid anyway. So there are a bunch of limits in terms of how many inputs are required versus how many outputs for a consolidation transaction to be considered a consolidation transaction. And if it doesn't meet those limits, then it's just treated as a normal transaction and will more than likely be rejected because of the fact that it doesn't have a fee. So because those rules are actually quite complicated, and I'll show them to you in a moment, we've come up with some rules of thumb that basically give you a very wide margin for error. So here we've said we suggest that you consolidate at least 100 inputs to one output. In reality, you can probably get away with as low as 20, but there are other conditions that will then come into play. But if you're using regular, pay-to-public key hash inputs, then it becomes simpler. I only use inputs that have been confirmed for at least 6 blocks. There's a particular reason why this limitation is imposed, which I won't get into now, but it's relatively easy to meet this condition, because even if you don't check that all of your inputs actually pass this test, you can still construct the transaction and then just wait for an hour for 6 blocks to get mined and then submit it to the network. Things are simplified in terms of evaluating whether it's a valid consolidation transaction if you use standard inputs like pay-to-public key hash or multi-sig with no more than 2 signatures. Again, you can get around that as a limitation, but it doesn't mean you've got to go into the detail of what defines a consolidation transaction. And okay, this box is probably meant to pop up a third. And that's what I said before, is the 6-block confirmation rule is relatively easy to get around just by delaying the sending of a consolidation transaction by an hour. I don't think that's actually significant blocker for someone who's using consolidation transactions as part of their business model, because they have to wait for significant numbers of these inputs to accumulate before they can make consolidation transactions anyway. So that delay between receiving the first of the set of payments and the consolidation is already inherently part of the mechanism. So this is the actual formula. And if I recall rightly, I think this might be from a Python script, so you should be able to cut and paste that into a Python interpreter relatively easily. As you can see, it's a lot more complex, and I'm not proposing to go into all of the detail, but it is explicitly documented, and this example script, of course, will tell you whether your transaction is consolidation or not. The good news is, if it's not, it will no doubt be rejected by a miner. They won't accept it into the mempool. There's no double spend issue to be worried about. So you can just basically modify the transaction and try again. And that brings me to the end, I think, of consolidation transactions. And I'm going to hand over now to Mate to cover the next topic. Oh, the hot topic, ancestor limit. Thanks, Mate.
Yeah, thank you. Can you please enable? Oh, thanks. Okay. So yes, for the grand finale DevCon, we'll take a look at two areas that sparked a lot of recent interest. The first one is removal of dreaded 25 transaction limit. This limit means that the transaction can only have 25 unconfirmed ancestors or descendants. And transaction dependencies are natural in Bitcoin. Here are two examples. If I go to a shop and buy a $5 item with a $10 bill, I will get back some change. And I can use this change to buy something else. That second transaction now has one ancestor. And the limit prohibits me from making a lot of such transactions in a short time. But besides the monetary value, transaction can also carry information. Let's say that a transaction represents a move in an online game, and that dependencies between transactions represent dependencies between moves. In this case, the limit restricts the number of moves that can be played by a player in 10 minutes. That might be okay if you're playing correspondence chess, but not so okay for other games. So the limit has been put in for wrong reasons, and we'll take a quick look at how it was removed. The second topic that we'll touch is double spend attempt notification. If you're a merchant that you have just received a payment from your customer, you want to be notified if customer is trying to spend coins for something else. And double spend notification will deliver you a warning when something fishy is going on. Some deep architectural changes were required for removing 25 transaction limit, and we'll just take a look at two of them. Block assembly and the mempool. So imagine that you're a miner and you have a mempool full of transactions, but your block size is limited to 1 megabyte. So what can you do? You need to decide which transaction you will put into the block. You cannot take all of them. So you sort the transaction by fee and only pick the most valuable one, leaving all the others in the mempool. That's why on some blockchains, customers have to pay up to $50 or more when buying a $2 coffee. To further complicate things, transactions are dependent on each other, so you cannot just pick a valuable child without including its parent. This whole process is quite CPU intensive, and in some old node versions that were used for performance measurement, it could took up to 28 seconds to assemble a big block. And this process of block assembly is repeated every time a mining software requests a new block candidate, which is every 30 seconds, leaving only 4 seconds per minute to do some other processing like transaction validation. Clearly, this is not the right approach, but it's the price you pay if you only handle small blocks. So can we do better? If blocks are big enough, we can just take all of the transactions that are in the mempool and put them in a block in one go. And that's what the new German block assembler that was introduced a few versions ago in the Bitcoin SV node software does. Okay, I oversimplified a little bit. In order for transaction to get included in a block, it needs to pay a minimum mining fee. So what we did in the BSV node software is that we split mempool into logical segments. The primary mempool contains transactions that pay enough fee. This is the part that will get included in the block. And the secondary mempool contains transactions that do not pay enough. We still want to validate and process those transactions because somebody else might mine them. If this happens, this speeds up a block validation because we already validated the transactions. And keeping those transactions around also helps with double spend protection. So when a transaction comes in, we put it in a primary mempool if it pays enough fee. If it does not pay enough fee, we put it in a secondary mempool. If new transaction depends on another unconfirmed transaction, we just link it and attach it to its parent. It can also happen that one part of the chain is in the primary mempool, but the rest of the chain is not paying enough, so it ends up in the secondary mempool. But what happens if a high fee transaction extends the chain that is already in the secondary mempool? Well, if it does not cover the debt that was accumulated by its ancestors, the whole chain remains in the secondary mempool and maybe somebody else will mine it. But if it does pay enough fee to cover the debt, the whole chain will be moved to primary mempool. This feature is called child pays for parent. Some other Bitcoin forks remove this feature because it's hard to design efficient implementation for it, but not in Bitcoin SV. So those are two optimizations that were recently implemented in the BSV node software. There were a bunch of others. For example, there was a destined count metric that was used to remove the transaction from mempool when mempool was getting full. The algorithm was slow and did not work well, so we completely removed the destined count limit and implement a faster algorithm that removes just what is needed and also removes the transactions from the end of the chain tips. So the results of all these optimizations can be seen on those three charts that show time that is required to submit 2 million transactions to the node. Left one is 2 million independent transactions. The middle one is 2 million transactions which are organized in chains of length 50. And the last one is for chain length of 1000. The blue line represents the software before the optimization, and the yellow line represents the 107 version that was released recently. So we can see that when we do not have dependent transactions, both versions perform almost the same. But with chain length of 1000, the difference is striking. The new version is as fast as for independent transaction. It's actually a little faster because it does not have to do a UTXO lookup. Coins are already in the mempool. But the old version, blue line, can take several hours to process 2 million transactions organized in chain length of 1000. So to sum up, if your transaction is paying enough, it will go directly into the primary mempool, which currently supports chains that are 10,000 transactions deep. Okay. If the transaction is not paying enough, it will end up in the secondary mempool, which is smaller, 10 times smaller by default. This means that your transaction can get evicted, but it's still useful for double spend protection and for speeding up block validation. It also does not support long chains. Another consideration thing that you should take into account is that if you're submitting very complex graph at very high speed, the transaction can get mixed up during propagation to the network. If this happens, if a child arrives before its parents, the child will be put into the orphan pool where it will wait for parent to arrive. And when all parents are present, the node will validate the transaction. This can extend transaction propagation time. Okay, now that we demonstrated that BSV can process very long chains, let's move to a double spend attempt notification. Double spend attempt, okay, is when somebody creates two transactions that try to spend the same coin. And since a coin can only be spent once, this means that something fishy is going on. So how does the notification work? Merchant receives transaction from a client and sends it to the Bitcoin network through merchant API, which is an easy to use REST endpoint for submitting transaction. As Steve has already mentioned, when submitting transaction, merchant can subscribe to different services and notification about important events related to this transaction. He can get notified when transaction is included in block to get the merchant proof, or when a double spend attempt is detected. So let's say that customer now wants to cheat and creates another transaction that spend the same coin as the first one. He submits it to the network, hoping that the second transaction will be mined instead of the first, and that he will not have to pay for merchant services. So what happens next is the following. When the second transaction reaches the node marks it as invalid, since its inputs were already spent by the first transaction, and it notifies the merchant API. Merchant API finds out that merchant subscribes to the notification service and fires back a notification towards the merchant. Merchant can now refuse to deliver service to a customer, or he can ask customer for another transaction. But that's not the whole story. Let's zoom in. The merchant API can only report double spend notification if the double spend attempt, if the double spend was detected by the node that the merchant API is connected to. So what happens if the double spend attempt is detected somewhere deep in the network? Let's say that the original transaction propagated through most of the network, but did not reach some of the nodes. So the evil customer can now submit a double spend transaction to the node that did not receive the first transaction. And this node starts propagating transaction to other nodes. Sooner or later, it will reach the node that already has the first transaction, and the node will detect a double spend attempt. But what happens now? This node has no idea where the first transaction originated from, and is therefore unable to notify a merchant and market. So there are at least two ways how this could be solved. We could introduce a new peer-to-peer message for double spend notification. The message would then be propagated through the network, hoping that it will reach the node that is attached to merchant API. Each node in the network would need to validate this transaction, and this is quite expensive, especially if the whole network is doing it. And it could also be impossible if you're a node that does not have both transactions. So since the attacker does not have to pay for double spend transaction, it will never get mined because the coins were already spent by another transaction. This would open up an easy spam attack vector on the network. But let us think again. In reality, there is only one actor which is interested in double spend attempt notification, the one who is receiving the money. In our case, the merchant. So the rest of the network really does not care. So why don't send the notification directly to the person who is interested in? So how does this work? The merchant is interested of getting double spend notification, so he can request that the customer gives him a transaction that contains a special op return. This output instructs the node to trigger a callback if it detects a double spend attempt. The special output contains different pieces of information. It starts op false, op return, and then the protocol identifier. But the most important part of this is list of IP addresses of callback servers. So merchant could run its own callback server that could process the notification, but we expect that this will be the service that will be set up by a miner. The latest merchant API release 1.3 includes a callback server as a reference implementation that fully implements this protocol. So when the node detects a double spend, it retrieves the IP addresses from the op return output and queries the remote endpoint to find out if it's still interested in the receiving the notification for this transaction. And if the remote endpoint indicates that it's still interested and that it implements the protocol, all details are sent over, including proof that can be used to check the double spend indeed occurred. In first version of protocol, the proof consists of the whole conflicting transaction. In case of merchant API reference implementation, merchant API server then triggers a callback to SPV channels or another mechanism to notify the merchant about a double spend attempt. So to close up, we've seen how each release of Bitcoin SV node brings up performance improvements. The 107 version included major refactoring that was required for lifting 25 transaction limit. The 108 version, which is now in beta, includes further performance improvement for complex graph. It also includes two important changes. It increased the ancestor count limit from 1,000 to 10,000, and because of the other performance improvement, it was also possible to change how ancestor count is calculated. The 107 version could count a transaction multiple times if it was reached through multiple paths, but 108 version now uses graph height when calculating the limit. This means that you can now have much wider graphs and much more complex graphs. And for upcoming 109 version, we still have some tricks hidden in our sleeves. And we expect that limit will eventually be completely removed. The new double spend mark transaction is the last missing piece of the puzzle that enables us to detect double spend which occurs deep in the network. And as Steve demonstrated, there are other important changes in the latest release. So developers, it's now to you to start using these features in your applications. You can find more info in the official documentation. Thanks.
Thanks, Mate. And out of all of those features, I know the one that has probably had the most attention in the last couple of years is the ancestor limit. I'm personally quite partial to the double spend notification mechanism because it is the last piece of the puzzle, as Mate said, to providing what is effectively complete double spend protection if it's important to you. Of course, it's an optional feature. There's plenty of use cases where you may not need it. But if it is important to you, then once this is widely adopted across the network by all miners, it effectively becomes impenetrable.
And we're back for some live Q&A on the previous presentation, and I'm joined by Mate. Hello, Mate.
Hello.
So we've got a few questions here, and I will start with one that I think is probably for me. How is dust return any different to a normal false op return transaction? I think they're probably curious as to why they couldn't just use and what's actually new about this. The key difference is that a dust return transaction is allowed through with zero fee, whereas a normal false op return output still requires a fee to be paid, and that's effectively what makes this useful, because regardless of the size of the dust input, the transaction will be allowed to go through and convert it into a minor fee. Next question is there's one here. Okay, is the secondary mempool chain limit of 25 going to be lifted as well? Why is it treated differently? I think this one's for you, Mate.
Okay. So the transactions that go into secondary mempool are transactions that do not pay enough fee for current miner. So they're still related to the network and can be mined by somebody else. And for the transactions in the secondary mempool, there needs to be some additional accounting made to calculate when they can be promoted to the primary mempool. So because there is more work required for those transactions, and because they are not getting mined by current node, the limit is still there. So as I explained in the presentation, if you're paying enough, you will go directly to the primary mempool. If you are not paying enough, then your restrictions are more severe.
So essentially, if you want to make use of long chains, then it's best to include a full fee in all those transactions.
Yeah, you will have to pay it eventually if you want to get the whole chain mined. So why delaying paying the fee?
Yeah.
There's no point in it here.
Okay. Our next question is from Maria, and she's asking, does there exist any template code for Dust TX consolidation? I think she means Dust return transactions or consolidation transactions. And probably if she'd asked the question a bit later in the presentation, she might also be asking about creating the double spend notification outputs. The answer to that is probably not yet, because we've only just made the server-side part of this feature available. And typically the way these things roll out is we make it possible to do, and then wallets start to take a look at it and start implementing the features that they want to use. I think there is certainly a role here for libraries libraries that assist with constructing transactions to be able to have some sort of convenience methods for adding these sorts of capabilities to an existing transaction. We would certainly be intending to do that with the Light Client program, with the transaction constructor component. But there are other libraries out there that I think are probably good candidates for this. TX Forge is one that springs to mind, but I'm pretty sure that there are many others that already have the basic functionality needed to be able to add this on top. And we've got a question. Can I pay fees with Dust only, Mate?
Can you pay fee with Dust only? So free consolidation transaction and pay fees for the whole chain? Is this the question?
I'm not entirely sure. I think they're asking, can you use Dust on the input side of a transaction to cover fees? Although just a regular transaction.
You could cover fees for the same transactions, but not for previous. Okay.
Yeah, I think this is actually part of the reason why the definition of Dust exists, because the point of Dust is that by adding that Dust input to a transaction, you're actually increasing the transaction size and therefore the fee that's required for that transaction. And the Dust threshold is basically the point where that increase is less than the amount of the input itself. So you're actually going backwards by trying to do this. You're increasing the transaction fee by more than the amount that you're adding on the input side of the transaction. So someone is asking, my understanding is that the Dust limit is currently in enforcement. How can a user create 10 Satoshi outputs in the first place? There's a couple of different ways that could happen. One would be that the Dust limit is not universal. It's set by individual miners. So you may have some miners allowing those transactions to be created. But I think the short answer is for the purposes of that demonstration, we just picked an arbitrary number of 10 Satoshis as an example. The actual default Dust limit, I think, Mate might confirm for me, it's around about 135 Satoshis.
Yes, around this number.
Yeah. But there appears to be some fairly fierce competition amongst miners on this particular limit right now. So I would not be surprised to see that change in the near future. Mate, one for you. Can you use a consolidation transaction to clean up all the dust in your wallet in one go instead of using dust return with lots of individual transactions?
A consolidation transaction can take more than one input. So you can collect all the dust that you have in your wallet. But that's different than dust return. Dust return returns dust to miners. And consolidation transaction return. So that's the main difference.
Yeah. There's also a privacy implication to that, isn't there?
Yes, if you have multiple inputs in the single transaction, then somebody could find out that all the addresses belongs to you. So you need to decide what you want to do. Yeah.
Which is kind of the opposite goal of the dust return transaction. So it's possible to do that, but dusting attacks, whilst they happen quite commonly, I don't know that any individual wallet accumulates significant amounts of dust from these, or a significant enough amount to make it worthwhile doing. And then it becomes a question for the user of the wallet: is the complete compromise of the privacy of the wallet worth the few cents that you might get from consolidating that dust? As a merchant, if I use a special op false op return for double spend attempt notification, can I still add another op false op return output to the same transaction?
So the Bitcoin SV supports multiple long returns, multiple op returns for a while. Okay, so you actually can have more than one op return. So the answer is yes. Yeah, you can, for example, create data transaction that carries some data in op return and add this special op return output to get notified about double spend.
Yeah. Is dust return already available in Electrum SV wallet? I think this probably goes to Maria's question from earlier. I'd be very surprised if it does, because they probably only found out about it a couple of days ago. But I imagine that Electrum SV would probably be one of the first to implement it. Building a dust return transaction is probably the simplest of all of the three different types of transactions that we've talked about. So some template codes to do that would probably be fairly easy. The part that's probably more challenging is working out the user experience flow, because typically Electrum SV prompts you for a password or some authorization to sign a transaction. It can't just sign transactions and send dust returns back in the background when it sees dust. So it would probably wait for some user interaction and give you a prompt to say, do you want to clean up your wallet? But that's probably a question to maybe put to Hayden when he does a presentation later today. And the last question, I'm not actually sure what this one means, is are oracles actually needed? I don't know that we've actually got anything in any of those presentations that looks like an oracle. Mate, does that ring a bell for you?
It doesn't ring any bells,
Yeah, maybe you're referring to the use of MAPI or asking for a particular service provider to act as a listener for double spend notifications. I'll make the point that you actually can run that service yourself if you want to. If you're a merchant, for example, you might run your own endpoint to receive those notifications. So that brings us to the end of our questions, and we are bang on time. We're coming back in a moment to hear a little bit more about Handcash Connect. But Mate, thank you very much for joining us today and telling us about one of the hottest topics in Bitcoin, the limits. Handcash and Bitcoin SV almost go hand in hand. I don't think Bitcoin SV would be Bitcoin SV without having had Handcash around even before its inception in 2018. Handcash is a wallet that has an extreme focus on user experience, which is something that I think had probably been lacking for the previous 10 years in the wallet space. But they've also been working very busily on a lot of tools to enable businesses to create better user experiences in combination with Handcash. They are extending their reach into the world of SDKs, and to tell us more about it, I'd like to introduce the CTO of Handcash, Rafa Jimenez. I will never know if I've pronounced that correctly. So please, let's hear more. Rafa.
Hello everyone, I hope you guys are having a fantastic DevCon. And today what we're gonna do is we're gonna build our first Handcash Connect application, and that's basically integrating nano payments in Twitch. So let's get started. The first thing, of course, is I want to introduce you to Handcash. So Handcash is basically an ecosystem of different apps and different games where users have a single identity with a single balance account that can connect to all these apps and games. And that's possible, among other things, because we have some universal money that is called Duro. And Duro is not a new token, it's not a stable coin. It's just a unit of account for grouping Satoshis into packs or small groups of 500 Satoshis. So every 500 Satoshis equals to just 1 Duro. And this is just some branding decisions that we made. And the reasoning is, as you've seen today, there's many different use cases and many usages for the Bitcoin ledger, but we wanted to focus specifically on a universal money that was covering nano payments. So one very specific use case using one very specific brand, so we can target better. Also, we think Duro sounds better for the average person. Sounds more like money, and having one very specific brand just for targeting games and apps with a universal kind of money, I think that's a very exciting concept. So this is how, let's say, the Handcash ecosystem looks like. So we have one user has his account with every user has a unique Handcash handle, and then you have things like, you have a display name, profile picture, many different things to customize your account. And then of course you have some balance in Duros. So every user can connect the same account to many different apps. And we have, in the left, Haze, Peer Game, BSB 2048, they are games. Also, we have things like Tonic Pow. There is a kind of very cool referral system where every time that you share a link, if someone is clicking on that link, you are getting an instant reward that is going straight to your account. Then on the right, you can see things like Twitch or Relica. They are social media apps, but with steroids, because every interaction is based on nano payments. So basically, Twitch, you can think of it as Twitter, but every interaction, like likes, retweets, even posting, it takes a nano payments, a few cents. So when you like a tweet, or a Twitch in this case, you are rewarding the content creator. Kind of the same thing with Relica. You can think of it as Instagram, but again, every interaction is a nano payment. So again, you are rewarding the content creator. And finally, on the bottom, we have TDXP. That again, it's a very a very cool concept. It's we can explain it very quickly as a micro trading platform. So it's basically for trading, for traders, but you can use very small amounts. So that's very cool to get started. And also, if you are very good at it, you can still make a good money. So the big picture here is we have many different apps, but every user has just one account that can connect to every of those apps. So there's no many sign up processes, filling boring forms, and most importantly, you don't have to be depositing money to any of these apps. Your money, it's all in a single place, and you have control over it. And also something that we think it's very cool is, as this is some sort of new economy, when you connect your account to all of these apps, you define your spend limits. So you can control and you can be aware every time that you spend or every time you reach to $5 or $10, and you can control how the cash flow is going. So with that said, what we want to do is we want to add one more app to this ecosystem. And our app today is what we can define as a Duro faucet on Twitch. So the idea is, on the Twitch chat, every time someone is writing the Hankes handle, we want to send them, boom, €5. That will be all. It's just that is the concept. Some prerequisites: we need a few things. We need a Hankes account. We need a Hankes Connect app that we have to register in the developer dashboard. And then the similar for Twitch, we need a Twitch account and a Twitch developer app. Yeah, so stop the bullshit. Let's do some coding. All right, so I have a BSB DevCon project with the npm initialize. I just run npm init, that's all. And now, first thing we need are we need a Hankes account. So you go to apps.hankes.io and create an account in case you don't have one. The next thing we need is to register our app into Hankes Connect. So you can go to dashboard.hankes.dev and register your app. So you just need to enter some application name, some basic details, application icon, and not even all of them are mandatory to start developing. Of course, if you want to send your application to production, you need to enter every field. So once we have that, I have this Twitch Duro application here, and the app ID, it's everything we're gonna need from here. And then we need some Twitch things. One is, of course, a Twitch account. Mine is here. Yeah. And then we need to again register a application on Twitch, which I already have one here, that is the Duro faucet. Then from here we're gonna need this client ID. Then this link, it's very interesting. This is the documentation in Twitch, that documentation, and there's one section especially for chatbots. So it explains here everything. There's some example here, which is very nice. And what it's basically doing is every time that you write one specific command, this dice command, it's rolling a dice, right? So we're gonna copy this code from here, and we're gonna start with our index file. We're gonna paste this, and we're gonna define some environment variables. I'm gonna paste, I'm gonna define the end variables. I'm gonna stop for one moment. I'm gonna stop sharing my screen so you don't sneak into my out tokens. Yeah, so to get our OAuth token from Twitch, we need to tap on this link. It's basically generating some OAuth token for chat. We just tap connect, and that's gonna give us the OAuth token. So we already have both username, that I call it DuroBot. Then we need that OAuth token that I just explained, and the channel name that is the name of our user in Twitch, or the channel name. And that would be all, right? So we're gonna run the example as it is. Yeah, so we need to install a few dependencies. That one for now. We should be good now. Yep, missed that one. Running now. We seem to be connected, right? So let's write dice on the chat. And that's working as expected. So let's check what's going on with the code. We have some TMA client, that is the some Twitch library. These are the options that we've already been through. Then we have to define some message handle and some connection handle. So basically that's there are some callbacks for when we are connected to the chat and for every time we receive a message. And that's the interesting part. The first thing is we ignore every message coming from our own bot. And then here is when we are getting access to the message. So here we remove the spaces, and then basically we try to match. If the command is this dice command, it generates a new random number for the dice, and it just sending the response to the chat. So what we want to do here now is instead of a command name, we'll be receiving here a handle, a hangers handle. So basically every time someone is writing their handle, we want to give them $5, €5, right? So the first thing we need to install the Hangers Connect SDK, which is over here. So we install it, and then so here we create an instance of Hangers Connect, and here's where we need our application ID. So we copy, we paste it here, and then what we need is, first thing is, in case we don't have a OAuth token from Hankaz, we're gonna paste here the link to get it, right? So go to redirection URL to get the auth token. So now we'll run this, and this is our redirection URL where every user in Hank that we want to get access to their account, this is when we need to redirect them. So this is what is happening. So we get some dialogue that is asking us as a Hankaz user to give certain permissions to any specific app. So in particular, this app is asking for our public profile, which is granted by default, and also permissions for paying. So we authorize, and then we are redirected back to the application, which in our case, is redirected to some Heroku app that I had set. This is the auth token that is part of the redirection URL. If we actually have a server, we should get this parameter from the request in our server, and then we can just store it or do whatever we need. In our case, it's way more simple than that. Anyway, we already have our token. We're gonna add it here as a Hankaz auth token. We paste it, boom. So now we already have it. Now we need to initialize a Hankaz account. So we can use Hankaz.getAccount from OAuth token, and this is our process.m.Hankaz auth token. So now we already have an account that we have access to, and the next thing we're gonna do is we're gonna change this code. So instead of trying to get a command name, we're gonna be seeking for a handle, right? So this should be, or let's say they are our arguments dot split spaces, and we need just two things where we're gonna get rid of that trash. Arguments.length equals 1, and the first and only argument that we have should start with $, right? So if someone is typing, let's say $Rafa, that should be correct. If it's saying $Rafa sucks, that will not work. Then we can get the handle here, which is arguments at 0. And now we are ready to send, right? So if we go to docs.hankaz.dev and we go to payments, and we can see exactly the code we need to trigger a payment. So we're gonna paste this, and we're gonna start personalizing that payment. So it will be something like, welcome to my channel, app action, let's say it's a tip, and then destination, obviously that's the handle that we just grabbed. Here we need to, well, let's just substring from 1 because we want to get rid of the dollar symbol, right? So it's just the handle, euros, and we are giving away €5 each time. Then we need that payment result. We need to make this function async, so we can add this await thing, blah blah blah, just pay. We get the payment result, so we are gonna be just printing it, and we're gonna send in a message saying I sent €5 to $handle. Boom. So that would be everything we need actually, right? So let's just run it again. Let's go to our channel and we're gonna write a Hank's handle. And that worked. That actually triggered a payment. But there's something, right? So if someone is, oh shit, the handle doesn't even exist. If someone is going greedy and just, you know, writing the same handle again and again, it's gonna be draining our wallet. So we want to control this, and already pay handles equals new set, and there's something around here where after getting the handle, if has handle we just stop it, and then here just after completing the payment we can just add the handle of the receiver, right? And maybe you want to give some feedback, so we can reply with I'm not giving you more euros. I'm not giving you euros again. Yeah, so let's restart and let's try to go greedy this time. RJC band. So first time we get some euros, and the second time, oh, it's not letting me. Then just quickly let's check our Hank's account. And these are all the payments that we've been triggering now. In this case, I was just giving some euros to myself, so that means that the balance or the amount of the transaction is 0, but I think you get the point. The wallet is being connected to this Twitch account, and we've been able to trigger a very simple payment. We've been going through the processing, how any app is asking for user permission to access it. So that was all the basics from my end. I hope that you enjoyed, that I was able to provide you some value. If you want to just check the code that we've been just writing, go to Twitch, Duro Faucet. And if you want to get into the details of the Hank's Connect documentation, just go to hankas.dev. So that was all from my end, friends, and I hope that this was very helpful to you. Thank you.
Thank you, Rafa. And that was a great tour of the Connect SDK and Duros in particular. We've got a few questions for you here. And the first one's a pretty straightforward one, I think, unless there's multiple answers, which is what language is Handcash written in?
Does it mean our infrastructure or the SDK? I'm assuming it's more for the SDK.
I'm thinking they're probably asking about all of it, unless some of that's a trade secret.
Jesus Christ. Or there's there's many different pieces. We have some JavaScript for Node.js, some Python, some Flutter, and then different database technologies, Postgres, MongoDB.
Mm-hmm.
It's just for the different pieces require, different solutions. So I think
So it's fair to say Handcache is actually a lot more than just the code that's running on your phone then. There's a lot that goes into supporting that.
Of course. Yeah, the architecture, most of the heavy lifting is done for our in our cloud infrastructure. And what is the user interface is just basically drawing the rest of the information. I think it will be most interesting if we talk about the different SDKs that we have, because Handcache Connect is based on HTTP calls. So we already offer some wrappers for JavaScript, for Python, for Ruby, also for Flutter.
Mm-hmm.
But there's many that we don't support yet, but any developer is free to just integrate them. They're just HTTP calls, and that's basically no limit.
Okay. And you mentioned different SDKs. Are there other SDKs outside of Connect?
I know, they are all Connect SDKs, but in different languages.
In different languages, yeah.
Today we cover JavaScript, but there's many others. Anyone can just check handcache.dev and everything is there. Okay,
well, I think you jumped ahead to one of the other questions, which is one that usually gets asked, which is where can we find the documentation, and is the example code you showed today available somewhere?
Yeah, it's on, maybe if I can share the link somewhere, it's on GitHub. If you guys go to the Handcache profile on GitHub, you can find the code demo from today, as well as all the SDKs we have, integration examples, everything should be there.
Okay.
Just go to github.com/handcache.
github.com/handcache. Okay. And handcache.dev is where the documentation sits. Is that right?
Yeah, that's right.
Yep. Okay. Mixup is asking, can I develop a standalone third-party Android app, not in the Handcache App Store, and use Handcache to authenticate and pay for transactions?
Yeah, you can. In fact, that's one of the use cases in general. The idea is that you don't develop a wallet, but that you develop some service, some app, or some game that requires payments, in particular nano payments. So instead of having to develop everything from scratch by yourself, that you can just integrate Handcache.
Yep. Okay. I don't know if you have had a chance to catch up on Dust return transactions in the new SV release 108 beta that's come out, but someone's asking if Handcache is going to support Dust return transactions.
We don't support any in particular. It's not about supporting features. It's about covering use cases. So for now, there's no use case in particular that we want to cover. What we are doing, it's been already more than 1 month or maybe 2 months, is consolidation transactions. They're very useful also in our ecosystem and for the people wallets. They have many UTXOs because we have high velocity, and at the end that can become an issue, because if you are receiving but you don't spend, then it's a mess, and it also compromises performance, because it's not the same having to sign maybe 5 inputs every transaction than if you have to sign 500. So we decided to take advantage of consolidation transaction, and it's been working great. It helped us to improve performance and also lower fees for our users.
Sure. Okay. Can you tell us a bit more about the message and data encryption features of Handcache? Is that part of the Connect SDK, or is that something else?
Yeah. we didn't cover that today. I consider it's a more advanced feature than just payments, so it's the basic feature we want to cover. But basically with that feature, what we provide is a key pair of private key and public key for every application and every user. And what you can do in the Handcash Connect is get access to that key pair. Then once you have that key pair, you can both encrypt or sign anything. This is a more advanced feature because it's not a high level feature. It's not a function that you can call to just encrypt everything. We provide raw keys, and you have flexibility, of course, but that's what we are supporting that feature. But also it requires you to understand a bit more of elliptic curve and these kind of things. So you should be able to combine this key pair with the BSB library from MoneyButton, and you are able to encrypt, sign stuff. Also, you can take advantage of some ECDH, so you can create some user-to-user encryption. And then in the integration example in our GitHub repository, there are some examples covering encryption.
Mm-hmm. Great. And is another, are you going to support it question? What about double spend notifications from Mappy? I'd probably bear in mind there's actually sort of two versions of this. We initially released the double spend notifications in, I think, October last year, but there was only limited support on the server side. So the recent release basically improves that support to make it network wide once the miners have widely adopted it. But is it currently supported in Handcash, and do you have any plans?
Yeah, not currently, but of course, that sounds like a very interesting piece. It makes life easier for any service using the blockchain. So as soon as we have a chance, I'm sure we will integrate it. Now we have some custom-made mechanisms, but it's not the same.
Yeah, I suspect that'll be an in-demand feature for merchant users of Handcash APIs. But I do recall, I think you actually did have some kind of mechanism. I remember a video of a Handcash wallet suddenly erupting into red flashing lights when it detected a double spend. Yeah,
that was for POP. It was a very small point of sale solution that we created at the time. In times, yeah. It was very cool, but also I think the Bitcoin network had improved a lot, because the main problem with double spend is the connection in the network, and what miners are not well connected. Also, we didn't have merchant API at the time. That also improves a lot this uncertainty with propagation. Once you get rid of all that things, it's really, really, really hard to double spend.
Yeah. Okay. I tweeted at Elon Musk this morning because he was trying to solve the fast payment confirmation problem by lowering the block size, lowering the block interval again. And I pointed out that we've kind of already solved that problem. But last question is about Duros. Will Duros always be a fixed amount of BSV, or will it change as the BSV price fluctuates? So I think they're asking, is the aim of Duros to be a sort of a stable representation of an amount of value, I guess, in fiat terms, or is it going to just be linked to BSV?
Yeah, it's going to be set to 500 Satoshis. In case that changes, we will create different units, because at the end it's a unit of account. So and it's not even a technical challenge. I mean, what is more important is what is important with the brand is that people, when they think in Duros, they think in this concept of universal money for apps and games. That was the main idea behind it. The rest is very flexible, so I'm sure if it changes, that won't be an issue.
Okay. The Handcash provides support for showing your balance in different currencies anyway, doesn't it? So that it's relatively easy to track your USD or GBP balance.
Exactly. Yeah, depending on
Yeah.
the context, maybe it makes more sense to use some fiat balance, or maybe you can also trigger payments in different fiat currencies. But again, the idea of Duro is apps, games with nano payments. So we don't have to be sending 0.000 whatever Bitcoin, or maybe 500,000 when that's actually 1 cent in fiat amounts.
And is it possible to transfer Duros into change Duros into BSV and back again? Is that a mechanism that's part of it, or is Duros kind of firewalled off in that way?
I'm not sure I get the question, but
so if you have one Duros is worth 500 Satoshis, can I convert that into 500 Satoshis and have it not be a Duros anymore? If I've collected enough, I decide that's actually a significant amount of money. I might want to spend that some other way. Can you transfer Duros, exchange it into BSV and back again?
Yeah, in fact, they are BSV, meaning it's
they
just
are the same.
Representation. We are just wrapping them in 500 Satoshis to show them to the user. And also, even if you have some balance in dollars, in euros, in anything, what you actually have is BSV. You always have BSV.
Okay, so there's no need to exchange it because it already is both.
Exactly.
Yep. All right, great. Well, that brings us to the end of our questions. We're going to take a slightly longer than usual break this time. In European terms, we will be back at 4:50 p.m., which is about just under 15 minutes from now. So take a bathroom break or grab a snack or whatever it is that you fancy. And we'll see you shortly for a deep dive into the crazy world of Push TX with Jiawei Liu. At the beginning of 2020, the Genesis upgrade activated and effectively unlocked the power of the Bitcoin scripting language by removing limits that restricted what kind of scripts could be accepted by miners, as well as restoring many of the original opcodes. Since then, there have been a few people pushing the boundaries of Bitcoin script and its capabilities in terms of smart contracting, but probably none more so than Xiaowei Liu from Scrypt. He has led the charge, I think, in the exploration of smart contracting capabilities, but particularly with a technique called, widely known now as Alt-Push TX. Alt-Push TX is an incredibly powerful tool because it enables a script to actually look at the content of the transaction that it's embedded in. It can sometimes get a little bit metaphysical even to try and explain it, because it does sort of sound quite bizarre that a thing can look at what it's embedded in an execution environment. But hopefully Xiaowei will be able to explain some of the finer points of it and explore some of the incredibly innovative ways that this can be used. So without further ado, I would like to hand over to Xiaowei to help us explore.
Hello, everyone. Welcome to 2021's Bitcoin SV DevCon. My name is Xiaowei Liu. I'm a founder and creator of Scrypt. Today, I'm going to talk about a technique called Alt-Push transaction, and talk about what kind of smart contracts applications can be built upon it. So let's get started. So I'll briefly mention about what this technique is, and I also mention about how it is implemented internally, and then I will show what we can do with it. And eventually, of course, I'm going to show some working demo, which I show you a fully on-chain Bitcoin game running on Bitcoin today. So what is a Alt-Push transaction then? So for people who have been into Bitcoin space for a while, we know that Bitcoin has miners, and miners verify transactions by using this native Bitcoin language called Bitcoin script. So basically, Bitcoin script is interpreted by all the miners in the so-called Bitcoin virtual machine. So Bitcoin virtual machine, they have the list instructions, which usually we call it opcode. So here I will show a few examples here. For example, opt2. So basically what it does is, because of the virtual machine is a stack based, so all the operations are going to be on stack. So opt2, it just pushes the number onto the stack. We also have op-add. Basically, it pops two elements off the stack and add them up and push the sum back. And we also have op-equal. So basically, it compares two elements on top of the stack, and if it's equal, it push one onto the stack. Otherwise, it push 0. So Alt-Push transaction, you can think of as another opcode that what does it do? It just push the current transaction onto the stack. That's it. That's it. So what is the current transaction then? So if you look at the right of the screen, you can see a diagram here. So basically, we have one transaction and another transaction, then spending it, transaction 2. So when the contract is always in the locking script, so when we are calling this smart contracts in transaction 1, actually, when we run Alt-Push transaction, it's going to push the current transaction, which is transaction 2, onto the stack. I think briefly we mentioned it will push the current transaction onto the stack, and actually that's not precise. So if you really want to be precise, what it does is it just push the current SIG hash pre-image on top of the stack. So what is this pre-image? So if you know about Bitcoin, when we just send normal Bitcoin transactions, funds to each other, so we always verify the signature is right? So what does the how does the signature come from? So basically, you first generate this pre-image called SIG-hash pre-image, and then you sign this pre-image with your private key. So this is what you actually sign. It includes most of the part of the transaction. So we can here see you have a version number, you have inputs, you have outputs, you also have end sequence and unlock time. And besides that, we pay attention here, you also have information about the UTXO that's being spent. For example, 4 and 5. These are the UTXO, and 6, the UTXO Satoshi amount. So I think we briefly call it opcode. Actually, that's not precise. To be 100% precise, that's if you check the list of all the opcodes available in Bitcoin script today, even we enabled all of them, you cannot find an opcode called push transaction. So in reality, it's implemented with existing opcodes. So you can think about this as a pseudo opcode, which is built upon all the other existing opcodes. So if you talk about when we talk about the Bitcoin transaction script, we always talk about the so-called ECDSA signature algorithm. So how do we use this algorithm to get the current pre-image? So we look at the diagram here. So we have a few steps. So first, after we have the pre-image, we sign it with a public key. Then we get a ECDSA signature, right? And then we use another opcode called opchecksig. Basically, it's just to verify the signature against the public key, which is derived from the private key. So if it says yes, then we are very sure this pre-image is actually the pre-image for the current transaction. Why? Because opchecksig, it just cannot check signature against any other data. It can only work if the current data being signed is a pre-image for the current transaction. So where does the private key and the public key come from? So this actually can be, because it's just to check whether the SIG-hash pre-image is for the current transaction. So actually it can be arbitrary key pair. It doesn't even have to be private. So this is how it works internal, how it's implemented. But the good thing about it is you don't have to implement it yourself. So at script, we build a library and high-level abstract already taking care of all the low-level details. So you only have to use it without, you don't have to understand how it's implemented to use it. So what you can do then, after we talk about, it seems like a very basic primitive, even though it looks simple, but actually can enable us to do a lot of things that's deemed impossible before. For example, you can control spending. So what does it mean? So when Alice sends Bob some Bitcoin, usually when Bob gets it, he can do whatever with it, right? So with outpush transaction technique, you can actually control how the receiver is going to spend his fund. So that's something that's impossible to do before. And also we have another big category of contracts that it only available to us because of this technique. Because basically you can maintain state within Bitcoin smart contract. So a very nice property of it is just happen to prove Bitcoin is actually Turing complete. So let's get to see some examples. First of all, let's look at the examples. How do we control spending? So here I have 2 examples. The first one is called check log time verify. So for people who have been familiar with script, there's another opcode called check, exactly the same name of check time log time verify CLTV in BTC chain. So what it does is, so for UTXO, for some coins, you can lock up the fund such that only after certain deadline you can spend the coins again. So the difference between this and the so-called unlock time is in terms of works on the level of transaction versus this works on the level granularity of coins, UTXOs. So how is this implemented? So if you look at if you know about the S script, so basically this is the main function here, public function called spend, and we pass it a parameter called transaction preimage. So in this line, we require the preimage has to be for the current one. So basically this line alone, this one single line, just check whether this preimage is for the current transaction using the output transaction, just one single line, and we are done. So after we get this preimage, we can pass it, right? So for example, here we have a wrapper basically helper, just can get the unlock time out of it. So we demand you can only spend this coin after the unlock time, if the unlock time is no smaller than the predefined mature time. So basically this basically says you cannot spend coins before the mature time. Basically implemented op CRTV, but with just using existing opcodes, thanks to the technique of output transaction. So the second one called pay to script hash. So for people who have been familiar with script, you know there's on BTC chain, there's also a way to unlock funds called pay to script hash. So here, what we do the same thing here, but just using that without explicit opcode support. So how do we do that? So again, we pass in the transaction preimage. We check is it for the current transaction. And after we have the preimage, what do? We demand this redeem script is hashes to the predefined script hash. Make sure this redeem script is correct. And then what do? We require the output has to contain this redeem script. So basically, this is one way to control how the next transaction's output is going to be controlled, how it can be spent. This new transaction can only be spent if you can unlock the new redeem script. So basically, you can achieve the pay to script hash but with two transactions. One, at once, when you spend this next, you have to provide the redeem script, measure the hash, and then in the new transactions output, you will contain this redeem script. And then you have a follow-up transaction, which can unlock the redeem script. So you achieve the same thing, but with just existing opcode, no change. Okay, so now let's look at some more examples. So we mentioned earlier, so we can actually using this technique to implement state within Bitcoin script, which is deemed impossible before this introduction of this scheme. So how does this work? So one way would be in the login script, we divide it into two parts. So we call it the code part and the data bus. The code part, so think about here with, you can think about it as analogous to object in object-oriented programming. So code part is equal to the login script is a whole as an object. The code is similar to methods in object-oriented programming, and data is just a state or properties and member variables in the object. So code part we maintain is immutable, so you cannot change it when you spend it. And data bus can be mutated. So I'm showing one example, the simplest example of maintaining a state called a counter. So basically, it maintains a counter every time you spend this. You call this smart contract. You spend this UTXO. You have to increment the counter by exactly by 1. So let's look at one example here. So here we have transaction 1, which is deploy this contract. So when the next transaction 2 is going to spend it, so basically this contract does two things. First, it checks, make sure the code part does not change. Okay. And then it makes sure the data part, which is the state, and here for us, in this simple example, it's just the counter has to increase by exactly 1. So you can see now the output, the code part doesn't change, but only the data part is incremented by 1. So if somebody wants to span this into another regular output, P2P cache will fail because the code, the output script will just not match the locking script as we demand in this original contract. So you can imagine once you have to go from 0 to 1, you can, if you pay enough transaction fee, you can go to the next transaction, which is transaction 3. It will keep going. Just every time you call it, you have to provide a counter that's exactly bigger than the one before it. So for example, here, if you want to using transaction 3 prime, so if you happen to use counter 3 here, it will fail because 3 is not equal to 1 plus 1. So in this simple example, we see how state can be propagated using push transaction technique. And what others can be implemented once we can maintain state? Yeah, actually there's because this state is just arbitrary data, so it can be any arbitrary program that you need to maintain a state, any arbitrary state you can do. For example, a big category will be fully on-chain peer-to-peer games. In this kind of game, not only the data part, but also the business logic, the code logic, the game rules is also enforced by the miners. So the on-chain games, you can have, we implement quite a few examples. For example, the Conway Game of Life, which I show on the right-hand side. So basically, this is the 2-dimensional cellular automata. We deploy this on mainnet, and because the Game of Life itself is Turing complete, by implement this directly on-chain, we actually proved Bitcoin itself is Turing complete. So it's very powerful technique. Even it looks simple at the beginning, at the first glance, is you can derive a lot of very sophisticated contracts out of it. We also have I think I'll go to show it later, based in tic-tac-toe, and they also implement rock, paper, scissors. So of course, everyone loves tokens. So because if you think about tokens, if it's fungible ones, the state is just one big giant token balance table. So you have one column says who's the token holder, and on the other column use the balance for this owner. So if you can embed this big table as a state and then propagate it, you get tokens. Also, of course, similarly, you can have non-fungible tokens as well. And also we implement some other financial contracts like options. We also even have token sale contracts. Also, we implement a checking account. So basically, you can spend, for example, you can set a daily spending limit on top of it. So you can never get withdrawn, or if you lose your, let's say, your private key, at least you have some level of protection. This make a lot of practical contracts. So enough talk. I think we talked about a lot of contract examples. So I'm going to show you one that's working on the mainnet today. So it's a fully on-chain tic-tac-toe. So basically you can go to our official website, script.io/tic-tac-toe. You can play with it today. So let me actually demonstrate how this works. So on my screen, I have 2 opponents, which I already set up beforehand. So we have on the left, Alice, and on the right, we have Bob. So Alice makes the first move. So now it's Bob's turn. Bob going to, let's say, make another move. He's press a big O here. And now it's Alice's turn. Alice can say, oh, let's place it in the center. So be careful. It's worth noting that all this moves, each move is actually a Bitcoin transaction. So for example, if you click here, you can actually take you to the block explorer, which everybody's favorite. I use what's on chain here. So basically you can look at each step. If you by clicking, you can see all this is actually on-chain transaction. Each of them is one transaction. So now let's keep playing. The Bob's turn. Bob, let's say, it's not super strategic. So he makes this fatal mistake. And if you are, Alice is going to make the next move. Okay, boom. She just won. So now all the funds that's locked up in a regional betting contract is going to be sent to her address. And but there's no way for Bob to cheat. So that's one of the benefits of doing a lot of peer-to-peer on-chain games, because it's transparent and everybody has to abide by the gaming rule. There's no way to cheat. So let's coming back. Okay, so we have demonstrated what the outpush transaction technique is. It looks very simple at first glance, but we briefly also talk about how it's implemented internally, which if you want to understand, you can understand. But this, because at Script we wrap it up in a very high level language and also in a very simple library. You can just with one line, you can use this technique. You don't have to code up anything. So once you have this technique built in, you can build a lot of contracts which was deemed impossible before. So I showed quite a few. For example, I showed you how to control the output of the spending transaction, and also I show you how to maintain state across different smart contract transactions, based on which we have a lot of other contracts. So if you want to know more, just go to our homepage at script.io, which we release all the code open source. We just mentioned all the contract examples like tic-tac-toe or game life or even auction. It's all open source. If from the homepage, you can go to our GitHub page. You are also very welcome to join our Slack channel. So, and we discuss all kinds of smart contract ideas almost daily. So it's a very good time to start building. Thank you.
Thanks, Xiaowei Lu from AirScript for a deep dive into PushTX. This is a huge subject, and I'm sure there's a few other areas that Xiaowei would be able to talk about. But let's begin with a few questions. Okay. The first one is about signature encoding. Does your implementation of PushTX convert a signature to canonical DER format? If so, would you briefly explain how it does it?
Oh, yes, because so
probably first be helpful if you could tell us what canonical DER form is for the audience.
Okay, I think probably I don't remember all the details, but to me it's so basically for signature it has different components, right? You have traditionally you have R and you have S, and you also have SIG hash flags. So for R and S, that's for each given value, there are many representations. So I think mostly for malleability issue, so people usually consider to convert it to some kind of like a standard form. Let's say S. I think most people just consider, so S, if you have a signature ECDSA, they usually, if you have one S, you can also take its complement. It's also a valid signature. So canonical meaning, general meaning, you convert it to the so-called lower. So I think R, maybe you have some notation for that as well. Basically, you have different representation. So you want to convert to some unique representation everybody agrees on. So there's no ambiguity. So yes, of course, because the Bitcoin specifies some unique representation, canonical representation. So to conform to the check sig, to pass the op check sig, we also have to, when we implement an op push transaction, we also have to convert. If it's not in canonical form, we have to convert to canonical form to pass the check sig.
Mm-hmm. There have been various attempts, I think, over the years to enforce canonical signatures on Bitcoin, largely to address the issue of malleability, which has often been characterized as an attack, whilst there are actually useful ways that you can make use of it. Effectively, malleability means using a different representation of the same signature, which effectively changes the transaction ID. But I've always made the case that you should treat malleability the same way that you treat a double spend. If it's intended, then that's probably okay. But a malleated transaction is effectively a double spend of the original transaction. It doesn't change anything unless that transaction has children, because the transaction ID is how the child references its parent. And if you get the malleated version accepted, then all of a sudden the children become invalid. So I would have to double check where we're at with that. I know it's definitely not enforced in consensus in Bitcoin SV canonical signature forms. It might still be enforced by a policy, but I can't recall if the default for that is true or false. So the second question, I think, relates to what you were talking about with pay to script hash. Someone is asking, didn't pay to script hash get removed in Genesis?
Yeah, that's a great question. I think the funny thing I always realize is when people want to change the protocol and to do certain things, like say push to script hash, pay to SH, it turns out with op push transaction technique, you can re-implement it with existing opcode. So that's what I mean. Is I don't mean we re-enable pay to script hash. We mean you can do the equivalent with this op push transaction technique. So basically what happens is, so instead of so you can, because with the op push transaction technique, now you can enforce the output, right? Not only you can say, oh, in the input you have to satisfy certain criteria like a valid signature or pre-image of a hash, things like that. But you can also specify the output. So what we do here is, so when you spend a coin, we also say, oh, you have to transfer the same coin to the output. So the output includes the so-called redeem script. So in this way, you have the same functionality, just without any change.
And there was another example, I think, in your presentation with op check block time verify, which we also removed as an opcode in Bitcoin. So it's an interesting example, or two examples of functionalities that were put into Bitcoin by changing the protocol through a hard fork that actually could have been done without changing the protocol at all. We've got another question here from one of our YouTubers. Can you create this sig hash pre-image within the BSV script so that individual scripts from the transaction are also available rather than just the hash of the scripts?
I think here depends on what you mean by script. Is it the unlocking script? Is it a locking script? I think for lock,
I think they're referring to the fact that one of the components of the sig hash is a hash of the outputs, perhaps. I think it's the output scripts. Okay. Yeah, I think they're asking, can you provide the actual scripts rather than the hash?
Yes, I think if you look at the preimage directly, you don't see it doesn't refer to the UTXOs that's referring to other previous transactions, because you can have multiple inputs, right? So but you can actually do this. But you have a little bit trick you can apply here. So basically, all the hashes of the input refers to previous transaction IDs are all part of the pre-image, but it's not directly there. It's embedded as a hash. So again, you can provide the pre-image of these hashes, and you check the hashes matches, right? Then you can get all the transaction IDs. And then if you really want to get to all the previous UTXOs or transaction you are spending, you can then do the same trick again. You can do the same hash paddle trick again. You can push the full transaction, previous transaction into the script, and you check this transaction ID. It is really the hash of the transaction, right? Now you got the full transaction. Once you get the full transaction, you can know everything. You just parse it, right? It's like any other. It's pretty well formatted. So you want to know the output, and you can also know the amount of the output. You can also know the locking script. You can also know the log type. You can know anything basically now. But it's through two directions, two hash patterns. You can do this. Yes. And for unlocking script, because it's not part of the pre-image, I think it's you cannot do it. You cannot do it. And I think it's this is in design because usually when in the input script, you have the unlocking script, which provides the signature, and the signature signs the pre-image, right? You cannot sign yourself, so that's why you cannot get the input script, the unlocking script, but you can pretty much get all the unlocking locking script, not only for the UTXO you are spending, but also for all the other UTXO other inputs are spent.
Yeah, that's part of the part where it starts to get a bit metaphysical, the signing yourself and the infinite recursion loops, which like does take a little while to get your head around, but it's a very clever part of this technique. I think the questioner might have actually been referring to the locking scripts on the output side, but the answer I think is still the same, that the sig hash pre-image effectively acts as an anchor, and then you can push any of those component bits of data and compare them against the hashes in the pre-image to validate that they are in fact correct.
So if you really want to get to metaphysical, so because you can apply this again and again, you can go all the way to Genesis, the first transaction, right? You can keep going. You know, it's now you're at a child transaction, right? You can, whenever you get a parent transaction, you can get your grandparent transaction. You can just keep going, but it depends on what you do. But, it's feasible, but I'm not suggesting you should do it. But it's just doable. Yeah.
So in theory, it's possible for a Bitcoin SV transaction to validate itself by proving its connection to the Genesis block. Next question is, how does a PushTX based smart contract differ from layer 2 type systems like Run, for example, in terms of utility as opposed to in terms of technology? Like what can you do with these that you can't with something like Run?
Okay, so here's the key difference between so-called layer 1 and layer 2. I usually I call them on-chain and off-chain. So basically, it's like any kind of a smart contract. You use smart contract only when it's good to use it for, right? So what does it solve the problem? The fundamental problem here, if you want to have minimum trust, you don't want to rely on trust third party, that's when you plug in. For example, right? So let's say even for, forget about the push transaction. I think this, you can apply to any kind of a contract. I think even for pay to public hash is actually also a contract. It's also enforced in script, right? So you can argue, so the analogy here is why do you do it run in script? Why not just post in Excel table? Everybody has a balance, and whenever you want to transfer, somebody who can write to this Excel table can just change the entries, right? It's end of the day, it's just a ledger. But here the problem, right? Who do you trust to change this ledger? If you have somebody you can find your trust, you can do it, but in general, if it's your Bitcoins, you don't trust any central figure to mutate this table. So that's why we usually use a pay to a public hash to do this transfer. So you don't have to rely on any single third party. You can just trust the miners. Because they are incentivized to do the correct thing. So you don't have to trust any third party. This is basically the difference between the so-called on-chain, off-chain, or so many people call it layer 1, layer 2. Whenever you don't want to rely on a third party for a lot of reasons, you better do it in script. I think you can only do it in smart contract in script. For if you can trust some let's say a token issuer, or maybe somebody is a escrow service or Oracle, you already trust them. In this case, you can get away by doing the layer 2, but everything else you have to, if you want to minimum trust, that's a keyword. Always, whenever you don't want to trust on third party to arbitrate, you can do it in script.
Yeah.
Same for outpush transaction. It's just another contract.
Yeah. So I might summarize by saying that Bitcoin itself has a very tried and tested trust model. And if you're going to make use of off-chain validation, then the onus goes back onto you to replace that trust model with something else, which is certainly an option. But it's nice to know that default trust model that works is there. Maria has got a question about whether oppushDX can be seen as a recursive function, and what sort of use cases are not good with oppushDX.
I wouldn't say it's recursive, but it's more like an introspection. Basically, it's like a lot of other languages. You sometimes I forget, is it Go or even Python? Or JavaScript. You can inspect when the code is running. You can inspect at runtime what's the context is running within. So for example, you can know what is its type, or what kind of properties it has. So similar here, it's like when the contract is running, you can know kind of the outer context, which is the transaction it is within. So the only case you need to use this is you want to get access to the transaction that contract is running within, right? So for example, when you do let's say hash puzzle, or just do even R puzzle, or let's say pay to script hash, if you're not accessing any field within the transaction, you probably don't need this step. So it's very simple. If you want to access the transaction context, you need this, but otherwise you don't need this.
I understand you've done a lot of work in optimizing the implementation of pushDX, and in the beginning, the scripts were actually quite large. How large did they start at, and how small have you been able to get them now?
Yeah, I think I don't remember the exact bytes, but I think it's around 750 bytes, if I remember correctly.
Yep. Okay,
and
so that's
now,
quite a small overhead.
Yeah, I think because we have this mentality. I think because I don't know, maybe it's just too much abuse from the small blockers. So anything that's like bigger than 200 bytes or something, somebody feels that's huge. But fortunately, after some optimization, we get it down to, I think it's about like 75 bytes or something. But it's like a 10 times smaller. Right? You can barely notice.
That's not a bad record for optimization then, a 10 to 1 improvement. Yeah. But yeah, no, you're right. As one of the limits that was lifted in Genesis was a maximum of 201 opcodes in a single script, which pretty much ruled out anything that was interesting. So I wonder if Maria's characterizing it as a recursive function might be a reference to the back to Genesis problem.
I see. Okay. Yeah.
Can you tell us what the back to Genesis problem actually is, and maybe tell us about some of the different approaches people have taken to try and address it?
Okay. Yeah. Very good question. I think this is still a challenge today. I think when people This mostly happens when people want to use this technique to do a so-called layer 1 token. So basically, before this technique, when people implement tokens on top of Bitcoin, usually we got this use the so-called color coins. So basically, you kind of like a color each UTXO or Satoshis with different colors with different tags in the so-called force of return output. So then you can externally, you have a third party that can interpret all this data embedded inside the force of return output, and then you can figure out who owns how many this token or that token, what's the transfer. But the basic line, the bottom line is all the validation is done not by miners. So that some people feel that's not ideal. They want to tinker on using all push transaction to implement tokens that's only enforced by, you only have to trust the miners. So the issue there is because the unique UTXO model, and whenever you receive a valid Bitcoin transaction that's already accepted by the miners, you cannot be 100% sure this is valid because let's say the easiest attack would be, let's say now you have issue 1 token, right? And it has let's say a chain transaction. It's just 2 people, or at most at one time you only have 1 owner. So think about this simplest example. So you just grow a chain, right? When you do transfer, and how do I attack? When you receive a valid transaction that's considered legit by the miners, I can also duplicate all that script you have. I create another chain of parallel transaction. So you don't know which one it is because to the miners it's all acceptable, but you have to trace all the back way to the genesis, so-called issuance transaction. Otherwise, you cannot know, is it really from the chain of tokens I'm looking at or not? So this is, I think that we have some ways to do it, but using this push transaction, because you can trace all the way. The problem is once you put all this previous transaction into the unlocking script, you have to do this recursively. So you just every time you transfer a token, the transaction size just grows. So depending on what you do, maybe sometimes you don't want to. You're selling a house or cars. You don't transfer that too often. That's practical, but if you have a, I don't know, ticket, movie ticket token, or some gaming item which can change hands often, then that's still an issue.
Yep. And this is an example of a problem that actually has many different types of solution, which you would pick those sorts of solutions depending on the properties that were actually important to you. But the fundamental problem probably still remains unsolved, and I think it's an interesting thing to note, because of push TX, this is really, really new territory. We really are breaking ground that has never been explored before, and so we're going to encounter problems that maybe for a while seem unsolvable, but push TX itself is an example that shattered the notion that a transaction couldn't actually introspect itself. So I would fully expect solutions to these problems to arise, but it's great to see the trailblazing that's going on here.
Yeah, I think one of the most impressive, if not the most impressive contract people have been developing using this push transaction technique is it's just some guy nobody knows in the community. He's in the middle of nowhere, and then he just created this contract basically using the push transaction technique and used to solve the token issue. It's not on token. Basically, you can solve it for any big state. Basically, we mentioned in using push transaction, you can propagate state. You can even prove this Bitcoin itself is Turing complete. So the problem is, for example, token, when the token holders gets big, right, millions or even billions of users. So the state, which is the table, gets big. So what he does is he uses the translate it into a Merkle tree. So you only have to store the hash of the root of this whole state table. You don't have to store every entry. At the same time, you can enforce everything is done correctly. So that's kind of I think you kind of like optimize from a big ON to big log ON. So now you have a billion transactions. You only need the Merkle root and the Merkle pass, which is like a 30 ways down. I think that's just in my mind, that's probably the most impressive usage I've seen, and it's done by somebody nobody knows. So it's very.
I hope they chucked a patent on that, because it's the solution to the global state problem that Ethereum have, in my opinion.
Yeah, so, I think after that technique, I wrote I don't know, kind of like a tongue-in-the-cheek article. I said how to scale Ethereum today, and not waiting for 2.0. So basically, actually, because it's a state model, you can just push the root of the state, and then every time you run the transaction, you just use a Merkle pass. And I've done some calculation based on the fee at that time. I think it's about 100 times cheaper than the mainnet. I think now, because the price grows up again, the Ethereum, I think probably now it's like 1,000 times cheaper if you do it on Bitcoin today using this Merkle pass approach.
It doesn't require sharding or any of the other Ethereum 2 magic that compromises the security of the system. So it's a very elegant solution. Yeah. We've only got a couple of minutes left, but are there any other particularly interesting things that you're working on in S-Crypt land right now?
Yes, I think just prior to DevCon, I think I released 2 contracts. Basically, I think somebody, Craig, doesn't like the term, but it's just how language work. I call it AI. I think most people just call it statistical learning or machine learning. I think it's basically from the idea, because some people may know I've been teaching this class. Now I'm learning the class basically with Craig. Every week we publish these videos and lectures. Basically, he's giving us ideas how to leverage a script to do a lot of things that previously thought it was impossible, like a push transaction, right? One idea he repeatedly mentioned is the so-called perceptron. So basically, is for people who don't know about this term, is it's like a new. People already heard about the neural networks, right? So it's a building block. So it's similar to like a neuron. So in machine learning, artificial neural networks, they call it a perceptron. So basically, it's almost like a gate in something like a big circuit. So once you have this building block, you can build all kinds of machine learning algorithm just running within Bitcoin. So I think I finally get implemented, and it's very elegant. I think people may want to check it out. I think this is so far most viral articles we have published so far. I think right after the Turing Complete one. So that's strongly encourage everybody to check into that if especially you are into machine learning or AI. So another thing we've been pushing about 2 months is a so-called a term I name it smart contract 2.0. Again, it's just the marketing trick. I think it's just a contract, but I think it's a fundamental paradigm change. Again, it's also coming from my talk with Dr. Craig Wright. Basically, a lot of time he's saying, "Oh, you don't have to put everything on chain. You don't." So basically, the idea is it's like a generalized contract idea, which is and the cool thing is almost like a tailored for a UTXO model. So basically, when you have you can have a on-chain part, of course, within the script, but also you can have an optional off-chain component. People call it L2. So basically, you can, if you design your smart contract smart enough, you can combine these two. You can also maintain the trustless nature of smart contracting. So you have an off-chain component, but the amazing thing is you don't have to trust any third party. You only, again, it's like you L1 plus L2, but achieve the same functionality with L1. So what are the benefits? Is of course it's much more cost effective because, for example, when you build a transaction tree off chain, so eventually only one pass can settle on chain, because each one UTXO can only be spent by one person, right? by one transaction. So you can pretty much, if you bring big ON transactions, you can bring it down to log ON. And another benefit is because you are not posting everything on chain, so people can only look at the path that get settled, that get actually run on chain. So they can only see the on chain part. They don't know the rest of the picture, right? So they cannot figure out what the contract is doing. So that's almost like a one stone kill two birds. So I strongly recommend people to go to our blog. I think this is I've been publishing about four examples. I think I have many more examples, and so now we have the 2.0. I think, and also AI. I think later on, probably before CoinGam, we have I think I'm not going to disclose now, but we have a very good techniques that's going to disclose.
I definitely look forward to.
Yeah,
definitely look forward to hearing more. And I've always wondered when Bitcoin was going to turn into an AI. Unfortunately, we've run out of time, but we'll be back in just a second because our next presentation is due to start in about a minute. But thank you very much, Jiawei.
Okay. Thank you.
Building and testing applications is always made easier when you've actually got an environment to work in. I remember my early days in Bitcoin, actually finding a way to test against the network was more of a challenge than it ever needed to be. But the Electrum SV team have been working on attacking this very problem, not only for their own needs, but they've managed to produce something that can probably help you. So this is probably one of the most immediately useful things that you as a developer can make use of get a hold of when you're starting your learning journey with Bitcoin. And to tell us more, I'd like to introduce Hayden from the Electrum SV team.
Hey guys. This talk's all about testing applications in a rig test environment and a dev tool that can make that easier on you. I go by the name OstiCon online, and you can find me on Twitter, Slack, or Telegram. And I'm involved with the Electrum SV wallet, and I'm the co-maintainer of the Electrum SV SDK, which is the dev tool that I'd like to show you, and also the maintainer of BitSV, which is a Bitcoin Python library. So as far as the pros and cons of the public test networks, so that being a testnet and scaling testnet, the main advantages of those are that they're very easy to get started with, and compared with a rig test, you don't need to run your own local instances of third-party services. And the other aspect is that it's a more realistic preparation for a production environment, because you do have the network latency effects, and depending on what you're doing, that might have quite a significant impact on the user experience. So there's that, and the disadvantages are mostly around a lack of control. So you don't control when a new block's mined. you have no control over when a reorg happens, and you certainly can't hit the reset button and replay the reorg again. And so if you've fixed a bug due to mishandling of a reorg, there's no real easy way to verify that you've resolved that issue. And so that's in contrast with the rig test, where, for those who don't know, the rig test is basically a private local Bitcoin network, and the difficulty adjustment algorithm is such that you can mine blocks on demand. So that's the main advantage, actually, that you can mine blocks on demand, because nobody wants to wait 10 minutes for a block. And if you know what you're doing, you can also trigger reorgs on demand. So what you have is you can handcraft raw blocks with the transactions of your choosing, with the keys of your choosing, and you can decide, at what block hash the reorg happens, and you can hit the reset button, so to speak, and replay the same event again. And so that lends itself very nicely to acceptance testing, and you can, if you're willing to do the work, you can add that to your CI/CD pipeline. And the other aspect is for benchmarking. Mainnet, if you're doing high throughput testing, mainnet is too expensive. Test network is not really meant for high volumes. It's designed for servers running on weak hardware, and the scaling testnet can be a bit intimidating if you're still prototyping. So there's that, and there's also the aspect that rig test removes network latency from the equation, and depending on what you're doing, that may or may not be an advantage. But personally, when I'm still prototyping something, I want to get my own house in order first before I worry about dealing with connectivity issues or third-party service provider problems. I just want to get my core business logic sorted first. And so now we're going to start looking at the SDK. I don't want to dwell on the installation. We have comprehensive documentation on our website, so you can go to the Read the Docs website here, and it's a Python application, and it's hosted on the Python package index. So most of the installation process is all automated, and you can check that out if you're interested. And so the main use case with the SDK is obviously running a node and topping up an address. And so the SDK works cross-platform. And so although the official binaries for the node software run on Linux, there are no official binaries for Windows and Mac. So what Roger and I have done is we've compiled native binaries for Windows and Mac, unofficial binaries, and only for use in a rig test scenario. But that's what we've done. So as far as I know, this is the easiest way to set up a rig test node on Windows or Mac. And I guess depending on how comfortable you are with things like Docker. So if I open up a terminal, so crash course on the SDK. So if we bring up the help menu, the main commands are start, stop, reset, and node. Node giving you RPC access to the running node. And if you've got multiple nodes running, you can specify which node you want to talk to. Start command So these are the built-in components that you can launch. And so if we want to start a node, by default, it will launch a terminal window with the logging output there. Stop the node like this. And then we can also, so if you're running on a remote server, you're actually going to launch the node in the background. So if you're using this for CI/CD testing, you'll actually have to use the background flag because it won't handle you launching a new terminal window in that setting. So like that, start background node, and then the logging output is directed to a deterministic directory. So there's the Electrum SV SDK directory, and there's a logging directory with each component, and so you just come in here, and so node 1 is like a unique identifier for this node, and we can have multiple instances, multiple nodes with their own unique identifiers. And so you come in here and you'll be able to see the logging for the node that's running in the background. Okay, so every component type has its logging captured and redirected in this way. So, so we've got a node running, and then we can start Electrum X. Console windows, and okay, so we've got a clean slate, an empty wallet, and we want to top it up. One thing you'll find is that on retest, if you have a fresh node, you do need to generate some blocks. You need to generate enough so that you actually have matured coins. You need to generate at least 100 blocks, and with one extra to start having enough matured coins. So I'll generate 200 blocks just to be safe. And 10 Bitcoins. And there's our transaction. So it's unconfirmed at the moment, so we can generate another block. And in a moment that will show confirmation. There you go. So the other use case is running a merchant API instance locally. And so if I flick over to the terminal window, so we already have a node running. So now if we start merchant API, we get this logging output, and it's configured to run on localhost 5051. And if we come over to Postman, and so when you first set this up, you'll have to add the node. So you'll have this in the body of the request. And by default, the node is configured to run listening on port 18332 for RPC requests. And the RPC user, RPC password, by default for the SDK node instance, it's always RPC user and RPC password. So this is what you send, and I've already run this command, so it's already been added previously, and now we can get a fee quote as an example. And if we wanted to look up the transaction that we sent earlier, we can come into get transaction, and then we need the hash from the wallet. So we would come in here. And there's the JSON response. So just to finish talking about the merchant API, so I think as block sizes increase, it's going to become more of a standard service that you run alongside the node. And so if you want to do end-to-end CI/CD acceptance testing, you will have to run the merchant API, a local instance of the merchant API. And what I found was that there are a few steps involved in setting up the merchant API at the moment. So you need a Docker installation, you need a node that's configured with all of the ZMQ endpoints, and you need a self-signed SSL certificate. Probably the last one, the SSL certificate, is the most annoying one. But that may be removed as a requirement in a later release. So, but basically with Electrum SV SDK, we've tried to take over as much of those responsibilities as possible. So the node comes pre-configured with all of the ZMQ endpoints. You don't need to worry about that. And we've removed the requirement for having a Docker installation. Basically, we've created unofficial binaries for each platform, and are standalone with all of the dependencies. So as far as that goes, it should work right out the box. But you still do need to do the SSL self-signed certificate, but that's all documented if you're interested. So the other main use case is obviously simulating a reorg. And so I'd like to run through an example where I'll basically reorg a transaction from block height 201 up to 202. And so obviously the block hash associated with that transaction will also change, and we should be able to observe the effect of that in the wallet. Okay, so what I'll show you now is if you go to the Electrum SV SDK source code, which is available on GitHub, I've included some example scripts of how to generate reorg blocks. So you've got a contrib and reorg. And so the first script, basically you can use the SDK as a library in Python. You don't have to only use it as a command line tool. So you have full control. You've got your start, stop, and reset command, and some other utility functions. So what we're doing here is starting two node instances with a unique identifier node 1 and node 2. And the first thing we do is to generate 200 blocks on node 1, and node 2 is insulated from node 1. So you can add them as pairs of one another, and in which case they would synchronize, but we're not doing that here because we want to create a fork. So we manually submit the same blocks to node 2, and then we create a pay-to-pubkey hash transaction to the first deterministic address, receive address of the wallet with 100 Bitcoins. And we save the raw transaction for later. And generate a block. So at this point, we have node 1 at block height 201 with the raw transaction with the transaction at height 201, and node 2 is still at block height 200. So now we generate an empty block on node 2 and add the raw transaction to block height 202. So I'll run that just to show you that it works. Okay, so now we have node 1 blocks. Each new line is a new block, and node 2 blocks. And we can now use this script to submit this to the node while the wallet is running. Okay, so in order for this to work with the Electrum SV wallet, we need to have hard-coded deterministic seed so that the receive address is the same every time we run the test. So that's a feature of the SDK, which is kind of tailor-made to our own needs. So basically, just run this command, reset it with the deterministic seed, and it will generate a wallet with the same seed every time. And so now we can start our components. Okay, so we have a blank wallet. So now if we come over to here, we can run the script to submit the first set of blocks. So we can see it's in block height 201, and if we want to, we can start up a what's on chain instance. See transaction is there. Okay, and next thing we can do is submit the second batch, which will reorg the first batch. So now if we have a look, same transaction ID, but it's at block height 202, and we check in what's on chain, and now the block height of 202, and there's our transaction. So as you can see, reorg testing is quite labor intensive at the moment, and you do need to roll your own scripts. But as long as you know the RPC ports the node instances are running on, there's no reason that you can't do all of this in any other programming language. You know, used to HTTP RPC calls, and you could interact with the SDK via the command line. And there's no reason why you couldn't automate that. So it's doable, but if there's interest for it, I would be quite open to baking reorg handling or reorg simulation into the SDK and making that more accessible, because I think it's a pretty important use case. So the other use case is benchmarking, and I think the main advantage with the retest environment is that you can run the same test under the same conditions, and while you're doing that, you can run fine-grained checks for correctness. Doesn't matter how fast your code is if it's not correct. And the other aspect is that depending on how you look at it, removing network latency effects and packet loss and fluctuations in third-party service providers, that might be an advantage or a disadvantage. But personally, I think it's an advantage. And what can also be useful is having the contrast between the two. So if you're finding that everything works perfectly in a rig tested setting, then probably your code is correct. Probably. And then if everything falls to pieces on the public test network, you're going to have a much more limited set of issues to go hunting for now, given that you know everything works fine in a rig test environment. And I actually have experience where I was having issues with packet loss, but only under heavy load. And it was incredibly difficult to debug. And it was only when I contrasted the two where I could show that it was definitely working on rig test fine. And but on the public test network, I was having these issues. That was the thing that allowed me to find the issue. And as soon as I set up a VPN, everything started working correctly. So that's a rare example, but that's been my experience. I want to throw in a bit of a disclaimer here about the SDK, and that is to say that the primary objective with the SDK was to support Electrum SV development. But with that said, it's a generic tool, and there's no reason why it can't be just as useful for any other kind of Bitcoin development. And so because of that, Roger and I thought we really ought to put in a bit of extra effort and make it more accessible. There are still a few limitations. So the main one is that the installation process isn't as streamlined as we'd like it to be. In an ideal world, it would be a one-click installation, but at the moment, depending on what platform you're on, there might be a few additional system dependencies that you'll need to install, things like Postgres, for example, or Node.js if you want to run the What's on Chain Explorer. So there's that, and we currently use the system installation of Python, and that does help streamline the installation process a little bit, but it adds some level of risk that we could have dependency conflict issues down the road. So that's we'd have a solution for that, which I'll talk about next. But yeah, and the other thing is a general rig testing. So if you are reliant on a closed source service or API, then that might be a deal breaker for you, because you need to run that service locally to do end-to-end rig testing. So I think the SDK has a lot of potential, and recently there was this tweet from George saying that Ethereum has these great dev tools like this one called Ganache, and is wondering if there's anything similar on BSV, and currently the answer is no, unfortunately. But this was a recent source of inspiration, and so if you go to the Ganache website, what you see is basically it's a one-click installation process, and so they have these bundled installers for each platform. I think they've done a really good job with it, because that's not an easy thing to get right. So they've got a bundled Postgres instance and Node.js and all the dependencies and a few other things. And so what you get is out of the box this browser-based GUI and a local node instance that you can manipulate, and you have everything you need for local development and testing. And so it's an open source project, and Roger and I had a look at it, and we think we could probably use a lot of what they've already done to get a head start on something similar. So, so that's a definite possibility. Yeah, so if we went this route, obviously we'd be able to bundle all of the things that are needed into a one-click installation process, so namely things like Postgres and Node.js and Python. And just going back to what I was saying earlier, we'd be able to also avoid using a system installation of Python. We'd be able to embed our own instance of Python and have all of the various libraries and dependencies bundled. So it's definitely something that we are open to as a possibility. So wrapping up, it's a bit of an upfront investment to set up a rig test environment, but I think it pays dividends and you're going to be rewarded with a faster iteration cycle. You're going to have more confidence in the end product. You're going to be able to test your application in ways that just aren't possible on a public test network, namely things like reorg handling, and it's great for benchmarking. And I think the BSV ecosystem's crying out for something like this. And I'm not trying to claim that the SDK is the perfect solution, but I think it's a start. And I think if we had something like Ganache, a one-click installation process and a nice polished GUI, I think that would be getting closer to the mark. And I think that would be something that would be very valuable. So that's about it. And I think now we have some time for questions.
Thanks very much, Hayden. And that looks like an incredibly useful tool for anybody who wants to spin up some Bitcoin development rapidly. Before we get to the questions about the Electrum SDK in particular, I'd like to point out you are actually a finalist in the very first BSV hackathon. Is that right?
Yes.
Yeah.
Yep.
What was that you entered? What was that you entered in, and what's its status today?
That was Polyglot, and that sort of is an extension of BitSV, which is the main library that I've been maintaining since maybe 2019. So that's like a cutesy little library that mostly allows you to do pay-to-pub key hash transactions and op return, which was all the rage back in 2019, but things have advanced a lot since then. So BitSV is sort of like quite a simple, easy to use library, and then Polyglot built on top of that to allow people to start using some of these unrider protocols that were, you know, all the rage back in around that time period. So I was wanting to, things like B protocol and C protocol and D protocol, and there was another one, things for signing images and these kinds of things. So I just wanted to have one tool that made it easy to interact with all of these different protocols. But I've sort of had to put that mostly on the back burner. I keep coming back to it, and there's been a few people submitting pull requests and things, but I just got so busy with other things, so I kind of haven't pushed it forward a whole lot, because a whole lot of other opportunities came up shortly after the hackathon, so I kind of got involved with a whole bunch of other things.
And did you ever envisage that entering a hackathon was going to lead to a change of career and full-time working on Bitcoin development?
Not in my wildest dreams. Yeah, no, I was, it all seemed pretty surreal, to be honest.
Well, you certainly produced some useful stuff. Then our first question is about the SDK itself. Like, what was the driver for building it in the first place? Was it your own testing in Electrum, and how did that lead to it becoming a product that you've gone and released to the world?
Yeah, so it was pretty much driven by the needs of Electrum SV development and testing. So we weren't, from the outset, we weren't really planning on, having this be something that's used by everyone, but we kind of did have in the back of our mind that it might be useful. But yeah, mostly things around like reorg handling's the big one, because you just can't do that without a retest environment. But also just being able to mine the blocks on demand and have that propagate through Electrum X and all the services that Electrum SV relies on. Like if you're debugging something complicated, you don't want to wait around for 10 minutes. It's not very productive. So that's been pretty handy just to accelerate development. And then of course testing. So currently it's still on the development branch, but we've got in the CI/CD pipeline just basic things like mining a block and then doing all the checks that wallet states correct after mining a block and doing the SPV verifications, and then a bit of reorg handling, and then benchmarking's another use case. Just being able to like dial in how many UTXOs you want to spin up to, and you know what I mean?
Yeah, certainly.
Yeah, reproducible benchmarks is one of the other use cases.
Yep. I can certainly attest to the value of being able to test block events easily, because I got my start in Bitcoin in 2011 working on mining pool software. And of course, you can imagine that the transition from one block to another was a fairly important part of that. But there was actually no such thing as reg test back then. So it was it could be quite a painful exercise. Would often involve using a test net that hopefully no one else had been using for a while, and then contacting a few of my miner contacts and asking if they could chuck some hash rate at it for a while so I could test something. So this would have come in incredibly handy way back then. So you have quite a few services there in the SDK, which sort of really starts to simulate a live environment. Like I really particularly like the fact that you've included what's on chain as part of it. Are there other services that are kind of common in the ecosystem that you're planning on adding at some point in the future? Yeah,
I think it'd be fair to say it wouldn't be complete without the miner ID and SPV channels, because later on down the road, if you want to do peer-to-peer payments and true SPV, so to speak, the SPV channel model seems like the way to go, because particularly just having that message box, whereas if one of the peers is offline, being able to have the messages accumulate and then have them pull those messages when they come back online, that seems like a pretty key component.
Yep.
So that would definitely be something we'd look at adding.
One of the direct drivers of SPV channels was to be able to handle online communications where both peers are online, as you would expect it to happen, but be able to gracefully degrade to a store and forward model if one of the peers goes offline. So a bit of a leading question, because I might already know at least one of the answers. You put this out there. Have you got anyone using it yet or planning to use it?
Had a couple of people have had a bit of a go with it, but we have it's. At this stage, it's only at sort of the minimum viable product stage, so we haven't kind of been going about trying to market it, too heavily at the moment. But it is in a working state, and I use it daily, like whenever I'm contributing to Electrum SV, every day, all the time. So it is definitely at the stage where there's no reason why people, couldn't start using it. Yeah.
Okay. MX1Up is asking, is Electrum SV a sponsored project? I think the answer to that is yes, right?
Yes. Basically, if you go to the electrumsv.io website, at the bottom there, you pretty much have your answer. It's Bitcoin Association, essentially. It's my understanding.
Yep. And that is largely because when the Bitcoin SV hash war happened, there were actually no wallets that were able to support multi-sig and several other features other than Electrum. So back then, Roger Taylor put his hand up, and it basically became an ongoing thing for BSV. And then you joined a while later, if I remember all the history correctly. The obvious question that always comes up in these Q&As is where can I find the tool? So if you want to give the URL a bit of a plug.
Sure. So the documentation website is electrumsv-sdk.readthedocs.io, and so there you find comprehensive documentation, how to install it for each platform, how to use it, all of that stuff. And that's probably the best place to go.
I recommend people go follow Electrum SV account on Twitter, because they're pretty comprehensive with their release announcements and things like that. So if you're ever looking for any Electrum SV related resources, just go have a look through their Twitter feed and you'll usually find a link. Let's just jump back to reorgs at the moment. It's interesting that you put such a focus on this, because it's an idea that I've been trying to push of late, that that applications should actually treat reorgs as though they're normal. So the confirmed status of a transaction isn't a Boolean response. It's actually potentially a set of chain tips with a different answer for each. Where did your focus on reorgs come from, and why did you decide to sort of elevate them in importance for your testing?
Well, I guess, to be honest, just to sleep better at night, because you want to have that well tested. You don't want to have that edge case and have, I don't know, people writing in with issues that have happened with, maybe balances not being displayed correctly in the wallet or something, something like that, because reorg's happening. And it's something that's so rare that, I don't know, you need to have a break test environment to test for that edge case and make sure that you're handling it correctly. So that's as far as I thought about it, to be honest. I just want the peace of mind that everything works.
Well, I think it's a critical edge case, and as we move forward, it may become less and less of an edge case as competition between miners hots up, and reorgs can potentially become more common. I think it's probably an opportune moment to point out some of the myths around reorgs, or rather that they're actually less of an event than people often tend to think, because people often equate an orphaned block with a transaction going from confirmed to unconfirmed, but that's actually usually not the case, because if you have two competing blocks, chances are that they will have almost all of the same transactions in them. And in fact, a double spend attack is no different in the context of a reorg than it is in any other context. However, having said that, you still want to know what the confirmed status of your transactions are in all competing chain tips for your application to actually understand the current state of play for a transaction. That's all the questions that we have for now. So thank you so much for joining us, Hayden. You're coming to us from New Zealand. I'm guessing is it the middle of the night there, or have I got my clock around the wrong way?
It's about 20 past 4 in the morning, but that's all good. Early start to the day.
Well, thanks so much for dragging yourself out of bed so that you could do this. We appreciate it.
Thanks for having me.
No problem. We'll be back in just a few moments with our final presentation of the day. It's David Case from Chronoverse. I'll tell you a bit more about that in a moment. And then we'll be wrapping up with a few closing remarks from myself and maybe an announcement or two. So we'll see you in a few moments. Chronoverse is a project that originated before Bitcoin SV and very rapidly came over when they realized what Bitcoin SV was capable of as a base platform. They've been working very hard on not only the Crypto Fights project, but its own underlying platform, the Fix SDK, building out features. And we're going to take a dive into that, particularly looking at NFTs and some other advanced use cases for the run on Bitcoin SV platform. So it's layers upon layers upon layers of platforms here. And to tell us more about it, we've got David Case from Fix and Crypto, or formerly known as Crypto Fights. He'll correct me on that. So let's go, David. Thank you.
Hello, my name is David Case. I am the CTO and Chief Architect of Fix Gaming. I've been a blockchain developer for about 3.5 years. I spent 1.5 years working in the Ethereum world, and then I've been a bit of a zealot in the Bitcoin space, especially Bitcoin SV, for the last 2+ years. Fix Gaming, we are the developers of Crypto Fights and the platform on which it's built. We started development on Crypto Fights in January of 2018. It was initially developed on Ethereum, and then soon after the Bitcoin SV BCH fork, we switched over to building on Bitcoin. So Crypto Fights is a turn-based PvP fighting game based loosely on a Dungeons and Dragons dice-based role-playing game fighting system, battle system. In Crypto Fights, players will fight against each other for cash prizes, cash in this case being Bitcoin SV, as well as build up their fighters and receive weapons and armor and other items which are all tokens on the Bitcoin blockchain, which can be bought and sold and traded and given away, and they are your property and they exist as Bitcoin UTXOs. So anything you can do with a Bitcoin UTXO as far as moving it, you can do the same thing with your property. I'd like to start off by giving you a bit of a demo of Crypto Fights, and then I'll dig into a little bit of the details of how it's implemented and what tools we offer which enabled us to build this. We start off by creating a fighter. You get to choose between 3 main races: dwarves, elves, and humans. I'm going to go for a dwarf here. And from here we've got standard ability to change what they look like, what their skin color, hairstyle, all that stuff is. I'm just going to take the defaults for now. And then you have different ability points you can associate to 3 different categories: strength, dexterity, and intelligence. Our battle system is very much based off a Dungeons and Dragons type system. I'm not going to go into the details here. You can join our beta and follow along and figure out how to do all those things. All right, I'm just going to give this guy a name of DevCon. And here we go. So I now have, I'm going to skip the tutorials. I now have a fighter whose name is DevCon. This is a token that lives in my wallet. It is my property. I can trade it. I can give it, transfer it to other people, whatever. All right, now I'm going to go into the caravan. So in the caravan here is where we equip our fighters for battle. So we've got different weapons and armor. Now, because this is a brand new fighter, we give you your first practice short sword for free. If you go through the tutorials, you can actually choose between a bow or a quarterstaff as well, but since I skipped the tutorials, I just get the short sword. All right, I'm going to equip him, and I'm going to go through and play one battle just to show you how that works, and then kind of go through our level up system briefly. So I'm going to enter the dungeons here. Dungeons are These are actually bots that you're playing. This allows you to kind of play through and level up and get some item drops and learn the game before you're fighting other players. So our first bot that we're going to match here, there he goes, frog named Boggart. And here we go. So we have equipped our fighter initially with 3 different skills that they can use. They can attack, which I will do first. You can hide, which uses kind of a magical spell to hide you from your opponent, which means they have to roll a dice to find you before they can attack you. And the last thing we've got is focus, which is boosts your ability to find them if they hide, or boost your magical abilities otherwise. So I'm going to hide here just to show what this looks like. Now the point of my talk here is not to actually talk through crypto fights. It's just to give you a basic idea of what the game looks like, how it works. But I should play out a battle first. All right. My hide missed last turn, so I'm not going to try to do another one. I rolled attack, and I have completed enough to kill my opponent. You can see his hit points right there are at 0. So now that I've won, I have a new weapon that got dropped to me. Now these are random based on the dice rolls that happen within the battles, so there's no control over what gets dropped at what times. These can be anything from poor weapons, common weapons, uncommon weapons, or even much higher, very rare weapons as well. So because I fought my first battle and won, now I get the opportunity to level up. Leveling up allows me to choose new skills to add to my fighter, or traits, where a skill is something I can do in battle. Any of these things that are in circles are skills, so I can do something like a power attack, which does more damage if I hit him, but it makes it harder for me to hit him. Or I can do traits, which are these hexagons here. I guess they're octagons. No, what are they? Hexagons? Octagons. Doesn't matter. And a trait is something that it just affects who your fighter is. So if I pick ambidextrous and I fight with 2 hands at once, or with weapons in 2 hands at once, then I get a bonus for doing that. I can also make it so I'm unarmed, which means if I don't choose any weapons, it makes me stronger. So I'm just going to choose ambidextrous for now. Actually, let me go over here. Also, we have, let me choose my elementalist here. This would give me spells to cast. So I could cast burn or shock or chill, which would all, well, they would be different ways of attacking the opponent rather than just hitting him with my sword. So, as I've fighting battles, I can at any point go into our Hall of Memories, which kind of shows all the battles I've fought. And these are all recorded on the blockchain. So, and they can be completely replayed, and this will be stored essentially forever. So at any point in time, we could go back and see every battle that we have ever played in our lives. You can go 20 years from now and actually check the blockchain and see the battles that you played in 2021. So some fun COVID memories. I'm going to now take you to our web portal. And this is our Data Explorer. Now I'll share with you right now that this portal is definitely still a work in progress, so it's going to get prettier. But the main functionality is here. So if I look through the games, these are other games that are happening within our beta test right now, and here's the battle that I just fought of DevCon versus Boggart. So if I go in here, so our battles, the entire battle itself, every move is recorded on blockchain, as well as every level up to the fighters, every experience points gained that they get. So we can see that here is every step that happened in our battle. Boggart won the initiative, went first. You can see here he attacked me, I attacked him. Let's see, here's where I attempted to use hide and failed. And then finally I won the battle. And you can see from this that I got a practice staff as a reward, and here's the details of what, well, just what the fight was. So if I click on my fighter, which you'll notice the images don't actually my image doesn't actually line up with what my dwarf looked like, but that's, again, this is an early stage on this page. So, but I can click through my fighter, I can see every fight that I've ever fought. I can go through, I can get a log. You can even watch a video of that fight, which I'm not going to bring us through right now. Additionally, and I didn't mention this earlier, but the items that we drop have the ability to be backed by different amounts of Bitcoin. So it's not only are they different rarities, so they have different strengths and weaknesses, they also have the ability to be backed by Bitcoin themselves. So if I click into this item within the My Item screen here, I can actually melt this for the Bitcoin that's stored within it. Now I'm not going to do that here, but for a practice short sword, it literally is just the dust that's stored in it. So trying to melt it will cost you as much to melt it as you'll get out of it, so it's not really worth doing. I can transfer the item, so I can send it to someone else, or I can sell it on our marketplace. This right now is using kilosats, kilosatoshis, so 1,000 satoshis as our unit of measure. I don't know that that's going to be what we're going to end up releasing with, but it works for right now. So if I sell this for, let's say, 500 kilosatoshis, which is 500,000 satoshis. I can sell the item, or list the item, I should say. And then if I go to our marketplace, you'll see there it is listed. Now this is an atomic swap system we've got built in, and it is also it's using the RelayX decentralized order lock system. So all our marketplace sales are completely compatible with RelayX's, and as theirs is also compatible with ours. And what's also really cool about this is anyone who wants to scour the blockchain for items that are listed that match, that use this lock, can actually do it themselves and can have their own shop. So I always love the idea of, if you're playing Final Fantasy or Zelda or something, and you go into the town and there's the little shop you go to where you can get rid of your old weapons and sell it to them, and then you can buy new weapons. Well, this is a world we can have where you can come to our place and do that, but also there could be listings that are just, people are just deciding to find what's available or make their own little trading shop and set up shop. And as we get to a future where there's an actual virtual world around this, you can be the actual shopkeeper in that little town, and you can list items and buy items. And I love what the picture that can do for the future. I'm actually just going to unlist this from right now because I can't actually use it. We've built much of our platform on top of Run on Bitcoin, which can be found at run.network. This is a great development platform, which if there's developers out there who are interested in checking it out, I highly suggest it. It's being used by RelayX, it's being used by us, it's being used by Duck Creations and a number of other projects out there. Probably one of the more heavily used development environments and more easily accessible development environments for Bitcoin developers. We've been working with Run for about 2 years. And I've been very close relationship with Brenton, the lead developer there, or the founder, I guess I should say. And I probably know more about it than anyone except for him at this point, because we've been with it since the very beginning. Anyways, Run, what it allows you to do is to create what they call jigs, which are, for all intents and purposes, you can call them tokens, but in reality, they're so much more than that. They are interactive, ownable objects. And the interactivity is all defined within JavaScript that's stored on chain. And the ownable part, any state changes that you do on an object are all defined within Bitcoin script, first layer Bitcoin script. So there is state change logic that exists above Bitcoin script, but at the core layer, ownership and being able to do an update on an item, or in order to being able to call a state change function, in order to do those things, you have to be able to spend your Bitcoin at UTXO that represents the item. And so that gives a ton of flexibility to combine both layer 1 Bitcoin enforced by miners script, as well as much more higher level, easy to interact with JavaScript code to build out your interactions. So I'm going to actually go to the Run Explorer to show you some code examples. Now this is our actual running in beta CryptoFights code. I'm showing it through the Run Explorer, and although you might think I'm giving you a behind the scenes look, this is actually on the blockchain. So I couldn't hide this from you. So this is all available. Everything that gets deployed through Run is unobfuscated. And if it runs standard JavaScript, for the most part, you can make it run in Run. Now, it doesn't work that great with external libraries unless they themselves are also runnable in Run. So you can't really necessarily use NPM packages with this, but as more and more libraries start building out, you can actually point to existing Run libraries. So as an example of that, I mentioned on our marketplace that we are compatible with RelayX. Now, it's actually further than that. We're not just compatible with RelayX, we're not using their API. It's not like we're cloning their GitHub repo and using that code. We are literally running the exact same code on chain, the exact same location. So when we list an item on our marketplace, it is using Relay's code. That is what is defining how those marketplace interactions work. And that is what makes it so there's complete interoperability between their marketplace and our marketplace. So I'm going to now talk through what a jig is a little bit and how it works. So a jig, as I mentioned, is kind of this ownable object. And as an example here, I'm going to talk through our fighter. So fighter that is our fighter. When we created the DevCon fighter a few minutes ago, this is what we created. And we've got our init method, which within a jig is essentially the constructor. I believe there was some issues with the sandboxing and how you could actually get to the constructor, so it's renamed to init, but this is our constructor. So when we create a fighter, we pass in who's going to own it, the race, the initial ability scores, what their appearance is, and their metadata. Those all get set as local variables. We set some initial variables that the player, the fighter, I should say, has 0 experience points, no bonuses, they're level 1, they get some basic skills. These are attack, focus, and hide, and also an initial skill based on what race they are. So there's a dwarves or an elves or a humans would get different initial skills based on that. So that's our constructor, and we have a fighter as it is. Now as soon as we enter the battle, a new jig gets created. And so how our process works is when a player enters queue, they go into a queue on our server, and our server finds 2 players that are compatible with each other, or if they're in the dungeons, it finds a bot that can play against the player, and it matches them together and it creates this battle jig. And the battle jig, in its constructor, will do various validations that the players are configured properly to fight with each other, and that the owner of that jig is actually owns the fighter and the items and everything that they're entering battle with. So when we create initial battle, we actually do this through a payment channel. So we create a Bitcoin transaction that encompasses, here are the players, here are who they're fighting, and this makes one big Bitcoin transaction. And like I said, because the ownership of everything is actually tied to Bitcoin UTXOs, this transaction template essentially gets sent around to both players to have them sign to say, yeah, they are signing on that this is a battle they're going to join, and they're doing that by simply signing the Bitcoin transaction and submitting it to our server, who then in turn broadcasts it. So that starts off our battle. So once the battle is begun, the players essentially take turns with our validator to play through until the battle is done. Our validator takes signed messages from each player and then reveals some random number and keeps track of time stamping for timing out if a player takes a minute or more than a minute, I should say, to take their turn. Well, that's beyond how much time they're allowed to do. So we do use our validator to handle things like random numbers and timeouts. Now the random numbers themselves, I won't get into too much detail, but that is a hash chain which ensures that we are not cheating and it's provably fair. where the timestamp aspect of this is more of an Oracle approach, that you are trusting our servers, that when we say what time it is, that is what time it is. And if it took longer than a minute for a player to take a turn, that just is, there isn't really a way to handle that in a untrusted manner right now. So that is being handled as an Oracle. Anyways, so as the fight goes on, we end up looking up what skill. So one of the things when a player takes a turn, what they're doing is they're saying, this is the action that I want to take. Well, we've got in here in this battle state, we'll see this battle players. We find out whose turn it is, or player to act tracks whose turn it is. We find out what skill they said they wanted to use. So we look up their skills and we find an instance of their skills. Now I wanted to show through those. So skills can be anything as simple as, here's our hide skill. It's very, very easy. It basically, what do we got here? We do, this is a very long line of code, but essentially we do something that checks out if it rolls the dice and figures out if they got it or not. It puts it in logs and it ends their turn. This is something that could be done on pretty much any chain out there. It's very simple. You could do this in Ethereum virtual machine. This is our attack code. This is not doable in any other blockchain that I'm aware of. EVM, you try building code that's, well, just simply the size alone would make this so this would eat up the entire gas of a contract. Not to mention the fact that this is just unadulterated JavaScript that we can do whatever we want with. So I'm not going to go through the details of this at all. I just wanted to show through that the different actions can be super simple or they can be really complex. And as long as you can get this deployed on chain, which means as long as a miner will take a block that's big enough to hold this much data, which that's no problem on BSV, you can make this code as complex as you want. Now, obviously, there are performance implications to making things too big, but we're nowhere near that at this point in time. So if I go back to my battle, it's going to go out, it's going to run. Oh, the other thing I wanted to point out with this code here is this is just a JavaScript class. So it extends a base class we've got that just kind of handles some things for serialization. But at the same time, this is not a jig. This is not an ownable property. This is just code that's deployed out there. So you can run this on-chain or from on-chain or from off-chain. It doesn't matter because all you're really doing is essentially requiring the data from on-chain. Requiring the code, I should say, from on-chain. So this is not a jig. This is just code. And with that, I can do pretty much anything. So in here, I actually call the run method on that. I pass in the current reference to the battle. I pass in the current state of the battle. I pass in a current dice, which are based on the random number that got passed in. I pass in the current timestamp. And what comes out is a new state. And so in that way, we basically can create actions which will modify our game state in any way that we want. And you'll notice if the timestamp is greater than the timeout from the previous turn that we set, then what we do is we actually skip their turn instead of playing out what that did. And the skip turn has its own thing, which sets whose turn it is to the other player. And yeah, it's another simple transition. And then finally, after we've calculated the player's turn, we then call this end turn function, which basically just determines if there's a victor or not. If there's not, we increment the user or the player to act, set the data to tell the user whose turn it is, and if there was a victor, we set victor. Also then, at end turn, when we call this begin method, so when we first created this battle, that was one Bitcoin transaction. Then when we called this begin, that started a payment channel, and the entire battle played out through that payment channel until this end turn function is called, at which point the validator will close out that payment channel. We were actually doing those without the payment channels, where every turn was a transaction. But the payment channel approach was an attempt to kind kind of mitigate some of the issues that we're still having with the ancestor limits, which hopefully will be fixed very soon, and we can go back to the actually every transaction if we desire to do so. So that was the second transaction of the battle. Then finally, the validator will call the finalize method, which will then go through and actually pay out the rewards. So it does that both with the monetary rewards of Bitcoin, if there is any, as well as calling issue rewards, which is another, this is actually not a class or a jig, but this is just a regular old JavaScript function that's deployed out there. So this code goes through and analyzes based on the dice at the end of the battle, at the end of the battle, analyzes, rolls the dice a number of times to figure out how many rewards you're going to get, what quality they are, and actually ultimately what those items are. And then when that pays out, the last step here is that this battle jig itself is actually transferred to the owner, and the experience points on the jig the XP property on the jig are set. So what this means now is at the end of a battle, a player has their fighter and they have their items, but they also have the battle jig. In addition, both players are given a battle, that is not it either. Oh, did I lose it? There it is. A battle token jig, which battle token is really just a way to say, hey, you were in this battle. And that helps a lot when it goes to indexing, and when we look up to see, okay, what battles was a player in. Well, the fact that they owned this battle token tells us that they were in this battle. So we're using jigs here just almost as a way of just keeping track of a history of what's there. This jig is not transferable. It doesn't really have any properties at all, except for just pointing to the fact that it was created from a specific battle. So by looking at that jig, I can actually get back to the battle itself, even if I was the loser and I never owned that jig. So, if I go back to our fighter now, we have this record victory method. So the user's wallet, or actually the game client in this case, will at the end of that battle, when they won, it will load up that fighter and it will call this record victory method, passing in the battle. And all we do here is just some simple validation that says, okay, do we trust that this battle is something that actually came from us in this case? And if we do, give the fighter the amount of XP and then destroy the battle jig. Now I want to show one other thing on the battle jig here, which is when we created it right now, we put at least 546 Satoshis in that battle. The current dust limits are about 273 Satoshis, or even lower if you're paying a lower fee than half a Satoshi per byte. By putting 546 Satoshis in this jig and having it destroyed within this function, what we're actually doing there is allowing those 546 Satoshis to become the transaction fee for this transaction. So it doesn't actually cost the player anything to spend this jig. It just costs them the destruction of the battle, which is how they gain the XP from that battle in the first place. So there's also logic here for leveling up and how additional skills get added, but the point here is this is an object, and this object grows and changes through the course of how you play it out. In order to build out CryptoFights, we've had to build out significant infrastructure in order to support what we're doing. And much of that we're going to be opening up to other developers in the coming months. We start with our portal, which I touched on very briefly earlier, but our portal includes a jig wallet, the ability to mint and melt NFTs, as well as our marketplace. We've got a crypto to BSV on-ramp with fiat coming soon. We've got the ability for games to create leaderboards as well as custom data explorers for different games. In addition, there's a number of API-based services. We handle all wallet UTXO management to handle both jigs and the Satoshis in your purse, which go to pay for different transactions. We have a run state cache, which is kind of a requirement if you're going to have any sort of performant use of run, just simply based on how their transactions build up over time. If you're going to load directly from the blockchain, it's going to take a while to rebuild the state, where if we've got an intermediate state cache, that greatly increases performance. We have a jig indexing service, which allows you to query all the jigs in your system based on who owns them, or what all the states of an instance, or all the different, you can query them by kind, you can query them by what is the current state. There's lots of different querying available through that. We have a signed message delivery service that will allow users and services to send messages amongst each other. Those are all signed with a player's Bitcoin keys. We've got a WebSocket implementation that allows push notifications of jig updates or messages directly to clients. So this allows for real-time updates. And then we've got a jig deployment process, which allows you to deploy complex dependency trees. And it uses actually an integration with Git to determine where there has been changes and what are the implications of those changes to the dependency trees. So that is what I've got to show you. So I'd love to open it up for any questions, and would love for any of you who are interested to go check out our beta at cryptofights.io. Thank you very much.
Thank you very much, David Case, for not only a technically interesting demo, but probably one of the more visually appealing demos that we see in the Bitcoin SV world. My first question I tried to answer during the presentation was, when can I start playing? I went to the website and that's not quite there yet. Could you give us an ETA?
Yeah, ETA is mainnet this week.
Mainnet this week.
That is what we're shooting for now. It is still going to be in beta. We're still anticipating some issues, especially until more miners start running 1.0.8 mining software. There's still going to be some issues probably with too long mempool chain errors and things like that, but it's going to at least be public and it's going to be running. So
great. Well,
take the beating if it isn't ready.
My email address is in your beta list as of about 10 minutes ago, so I don't know if you have to approve people or not, but I'm using my connections. Okay, so the chain limit, that's an interesting one. We've actually got a question from Lucas asking if the block time is 10 minutes, does it mean I have to wait 10 minutes to process an action, or how does it actually work? Maybe you could talk about that.
Yeah, so there's kind of two different aspects of that. One is we do rely on zero conf, the same guarantees that people rely on within financial transactions. So essentially, as soon as a transaction has been broadcast to enough miners that we feel comfortable with enough hash rate having received it, we just assume it's accepted and move on with it. So secondarily on that, we've gone through a couple different approaches of using different like payment channel approaches, or every move is a transaction. Currently, what is out there right now is using a kind of a batched payment channel approach, which means really there's kind of a setup transaction for a battle, then there's a completion transaction for a battle, and then there's another one to kind of pay reward. So we've kind of like all the turns that happen within that battle are kind of getting shrunk down into one payment channel transaction, and that offers benefits and it offers some downfalls. So it's just really, there's different ways of approaching it.
Okay. I mean, that is an issue that largely gets solved by increasing the ancestor limit, and that's topical at the moment because it's not just a matter of software supporting it, but adoption by miners. And to be fair to miners, it has only the latest update was only out a few days ago, and it is still in beta. So there may be a little more waiting there, but it's an issue whenever a feature is released that there tends to be some miners that actually just don't upgrade by default. What sort of impact does that have on you?
Well, in previous releases, it wouldn't have really had any. In this one, we've been chomping at the bit to kind of get out there for a long time. We've been talking about what we're going to do for 2 years now, 3 years now, and we finally got a point where it's like we've pretty much done it, and then waiting on just we need the network to be able to support the kind of transaction load that we generate.
Yeah,
the business model fits, everything else fits. It's just kind of that technical limitations of, okay, let's go.
This particular feature upgrade is one that you're highly dependent on, and I understand that there are some miners that are eager to get updated as soon as they've completed their testing. But is your use case dependent on zero conf, or rather double spend protection?
Well, I think that's going to have to come down to, there certainly could be little cases here or there that would cause a big issue. And we do, like I say, we are relying on the kind of the zero conf promise kind of filling out, holding out. We do, that is yet to be shown exactly how big of an issue. Now, what's kind of nice about just kind of how the whole UTXO model works and how our state model works is, if we do end up with any sort of like corruption at all, it's actually going to be limited to a very, very small, well, it's not really corruption. Jeez. You got me all frazzled, Steve. I guess I will say there probably needs to be some more thought into exactly how reorgs would get fully handled. That's not something we're worried about. We're very much using kind of the logic that you were saying earlier of basically the transactions aren't really getting reorged. What block they're in is, but that doesn't change the fact that they're being spent. And we rely very heavily on the chain of using one transaction coming before another to kind of to enforce the whole what sequence things happened in. And so in some ways, once you can rely on that, I don't really care where they come in a block.
Yep. I think you probably would be able to mitigate a lot of this, a lot of the potential problems if they happen through the use of the double spend notification feature, because that one actually doesn't require all of the miners to be updated. It requires a miner who has the update to detect the double spend transaction and then notify the registered listener endpoint. But because of the fact that double spend transactions, transactions themselves have been first-class citizens of Bitcoin forever, they will bounce around, and eventually one of those miners that is updated will realize that there's a double spend moving around. So that might be an area to look at.
Yeah, well, one other concept on that is we look very much at the signatures of players as, we rely on the fact that if there's a double spend, then both those transactions are being signed by the player themselves. So Run is very much about ownership. Like when you own a token, it's your property, and you are the only one. Like how Run is built, you have to be able to spend that UTXO in order to be able to change the state. So if you're double spending, you're essentially providing us signed proof that you're cheating. And so from a gaming standpoint, that's really kind of a dumb idea. So for the couple bucks you might win, you've already signed your own certificate that says I was involved in fraud. So congratulations, you're dumb.
You might even be able to code up a mechanism that can take two double spend transactions signed by the same private key as a trigger to nullify certain objects or something like that.
Yeah, and the other aspect of that, not to go too far down this hole, but all of our transactions from our game client go through our endpoints. So we know about the double spend. It's really only if someone is trying to work around the system and broadcast to other miners outside of our visibility. Because our client does, they do broadcast all transactions directly to us.
Yeah. Okay. Yeah, I think the double spend issue is often overplayed in terms of its significance and even quite often its impact when it happens. So just on this issue, you were talking about the current sort of payment channel batching mechanism that you're using as in the interim. Someone asked, what is the need for all events to be on chain? Wouldn't it be better to keep only the results on chain and events during the battle off chain?
Well, what you get is when you start having a graph of the actual growth of your items on chain itself, you can start getting and this is how we get to a Ready Player One universe, is when everything can point to everything else, which can point to everything else. And you have a graph of things that care about each other being able to point directly to where something happened, such that we can have commentary about our battles that can actually point directly to reference the actual point of the battle, where the commentary is involved on. So whether that be like a Twitch stream, or whether that be a chat room, or whether that be whatever. And then those things can also be timed. You can join those. Like, you can end up with this world where it really is the next generation of the internet. It isn't just, okay, I've got hyperlinks. It's literally the data, and which ties into the identities, which ties into the financial aspects. Everything, it is everything. All, I don't know. It's some next world stuff. The future is here.
There's a twist on that question, if I might indulge. Why not just store the results on chain and keep the events off chain? If you were still on Ethereum, that would probably be a viable choice, wouldn't it? Or maybe even a required choice.
Yeah, well, yes, absolutely. But you know what? Some of these things, the lines aren't that clear about, because like what's being stored on chain are a lot of times just references to other things that are already stored on chain. So it's not like it's this super huge inefficient process. I mean, a lot of times it really isn't a whole lot different from storing a hash, or like what the turns are just very small. They're very small bits of data. So it's not like there's huge amounts of data, because you can actually have stuff that does get processed. And the storage, like if someone wants to pull up a historical battle of ours, they're not going to probably go query it from a miner. They're probably going to hit our database where we have it, or they're going to hit the run database where they have it. And it's got the same transaction ID. You can verify it on the chain, but it's not like you're truly pulling it from the blockchain.
Yeah,
so
sure. I think there'll be many intermediate layer services between blockchain and end users. Someone's asked, would game items, they're imagining a world beyond just crypto fights, would game items ever be interoperable between games? Would that require some kind of item definition standard?
Yes, absolutely. It would require, well, yes, it's absolutely possible. Yes, they have to know how to talk to each other, but really the trust layer is where that kind of comes down to, of how do you determine which, like when I, in my little code snippet there, showed that with the battle, or the fighter consumes the battle to level up. Well, it has to know that that isn't someone else, the fighter just passing in some other little JavaScript object that happens to have an XP property that can get destroyed. We have to build it in such that it knows that it's really coming from us. But that trust layer can be anything. I mean, you could build second layer proof of stake consensus to be that trust layer. You could make that trust layer be whatever you want it to be, but you do have to have some way of configuring that, okay, I'm going to trust this other thing as being something that I'm allowed to, that I will accept in here. Otherwise, you just run the possibility of having your game logic be completely insecure. And in some cases, that's fine. Sure. I mean, if you're playing a game of chess and you want to play against a bot, it really is only if we're trying to reward people with something of value, well, we need to know that they really legitimately earned that.
Sure. So I can imagine perhaps those trust gateways, rather than a completely open system, you might end up with trust gateways that game owners might enable one by one. Apologies, I think I might be losing my audio feed. I'm going to hope that you can still hear me, David, and ask the next question. Oh, okay. No, I've got you back. Okay. So someone's asking, could the platform tech be taken to existing massive multiplayer online RPGs, MPORGs, and get them to switch over from whatever they're using now?
So eventually, yes. Right now, there's a lot of custom work. There's no generalization, I guess, as far as how you plug into. I mean, there is Run, and Run is a wide open platform, and you can, do very, very much with it. And we provide all sorts of indexing services and wallet services and things like that. But to get it such that an existing code base just plugs into this in a plug and play fashion, there's a lot of very custom coding that would kind of need to bridge that gap. And Run is great, but Run is JavaScript, and it's JavaScript only. And there's talk of, I know Brenton's working on getting a JavaScript VM that's in another library format that could be loaded into other stuff, or in a WASM format, so you could load it into other places. But right now, it means you have to have a JavaScript environment, and that's fairly limiting to plug in other code bases for a lot of purposes.
Sure. Okay. We've got time for just one more question, but there's actually a few more good questions here. So I'll just remind you, we'll get those questions over to David and see if he can give us a written response that we will get published for you at a later time. But this last one, I think, is a really interesting one. I've heard this question in quite a few contexts. If BSV becomes much more expensive, what is the strategy to reduce fiat fees?
So there's a couple parts of that. One, the fees are not that big of a portion of our costs. So the assumption is that miners are going to set their fees relative to what their actual electricity costs are. And at this point, their electricity costs are in fiat. So, I mean, obviously we have to, as a company, because our system does run on BSV, we have to have enough that we can afford to keep it running. And so that's just accounting processes of making sure that we're in fine shape there. But as far as the gameplay itself, there's nothing really frozen into it as far as what the costs are. There is the mining cost. And like I say, the assumption there is if BSV goes 10x, well, then probably miners are going to divide by 10 what they require for a mining fee, for a transaction fee. So roughly, I think we're going to remain in the same spot.
That's right. I think that's actually probably the same answer I would have given as well. When you have a world where most of the operators' fees are denominated in costs are denominated in fiat, then it makes sense for the BSV or the number of satoshis to float to reflect those fiat-based costs. But when we eventually get to a world where most of the costs are actually denominated in BSV, we've probably achieved quite a degree of stability in the BSV price. The other thing that's a possibility on the table is, which is actually possible with Mappy, is for miners to actually update their fees in real time, their fee rates in real time based on exchange rates. I wouldn't be surprised if we see that starting to happen in the near future. Well, that's all we have time for. So I'd like to thank David Case for joining us and giving us a very interesting look into the heart of Fix. I hope some of you are going to go and take a deeper look. And we'll leave it there. I will be back in just a few moments for a few closing remarks. So thanks again, David. We'll be back in a moment. And welcome back. And that brings us to the end of our presentations for BSV DevCon 2021. We've seen a lot of interesting pathways for developers to get into the development space in Bitcoin SV world, and a lot of really interesting tools. You'll be able to watch some of these, or all of these presentations again online, so you can go through them at a slower pace if you want to dig into some more detail. And of course, there's websites for almost all of these tools that you can go to get a whole lot more detail. So thank you for being with us for these last couple of days, and I really hope that you've taken away something valuable from it. I'm just going to remind about a couple of different things that are going on. Firstly, the Bitcoin SV Academy has launched the Bitcoin Essentials stream. It's now live. This is a series of shorter courses that cover some more sort of specific topics in Bitcoin, and as well as some background that might help you with some of the longer courses. So the first course in that stream is Bitcoin Basics, Protocol and Design. There's also the Introduction to Bitcoin Development and Introduction to Bitcoin Theory courses, which are more of the long form courses available. Just a reminder, all the courses that are currently on the Bitcoin SV Academy platform are actually free to run. So it's bitcoinsv.academy. Another reminder, the CoinGeek conference is coming up in June 8th, 9th and 10th. And that's going to be held in Zurich. At this stage, I think it's an online only event, but it obviously will be streamed. There may be some updates about that closer to the time. I'll be there presenting, and one of my colleagues from the Technical Standards Committee will also be there, and we'll talk about what the TSC actually is and how you can get involved, and more specifically, the technical standards roadmap that is currently in a process of public consultation, so that we can find out what the industry actually needs and what's on this roadmap. So I will be in Zurich for that, not too far down the road from where I am now. And finally, I would like to make an announcement. We had earlier Hayden Donnelly from the Electrum SV team on, who was a finalist in the very first Bitcoin SV hackathon. Well, I'm here to tell you today there is another Bitcoin SV hackathon starting on the 14th of June to the 26th of July. That will be the coding round. This is actually a long form hackathon this time. So 6 weeks of coding available. Finalists for that hackathon will then be announced on the 24th of August, and the winners will be announced at the next CoinGeek after this upcoming one, at a date to be announced. The prize pool is pretty substantial. It's $100,000 in total, payable in BSV. For first place winner will be $50,000 paid in BSV. Second place, $30,000, and third place, $20,000. So there's a significant amount of prize money on the table. And aside from really valuable learning experience these hackathons can be, and a whole lot of fun for some people, there's potentially a small pot of gold at the end of the rainbow to help you develop your entry into a real product. So it's a unique opportunity to build something on Bitcoin SV. You'll have access to support from some BSV specialists, including a team from nChain who'll be online helping with technical support. And you can get more details at bsvhackathon.devpost.com. That's bsvhackathon.devpost.com. No event like this would happen without the help of a whole bunch of people behind the scenes. So I'd like to say thank you to a few people. Firstly, to Mark, my very patient camera operator, who's been running in and out of this studio for the last 2 days, adjusting my devices. Richard from AR Media, who's been looking after the YouTube stream. The WeAreDevs platform. We've had Jerry Vasella and Vincent looking after us for the last couple of days. Kapil both from the BSV Academy and from nChain, who made a substantial contribution to the development of the content program here. And of course, from Bitcoin Association itself, I'd like to thank Martin, Laura, and Raylene, who have been behind the scenes making everything tick the whole time. And last but not least, a huge thank you to all of our presenters who not only have come and told us a bunch of interesting stuff, but have spent the last couple of years working and building so that they actually had something to show us. So hopefully we will be seeing some of you online or, well, I'm not sure how that will work, at CoinGeek in a few weeks' time. I look forward to it, and we'll see you again.